Welcome to episode 123 of ArrayCast. I am your host, Connor, and today with us we have our only panelist, therefore promoted to co-host, Adam. Introduce yourself briefly, Adam.
I'm 𝗔𝗿𝗍𝗪. I have a long history with APL. I currently work as head of language design and also doing a bunch of other stuff at Dialog Limited.
And as mentioned before, my name's Connor, host of ArrayCast, massive fan of all the array languages, excited for today's episode. And we do have, I think, 2 announcements from Adam. But before we get to that, I realized we should mention that we had a regularly scheduled ArrayCast, this ArrayCast episode 123, that was going to be with Henry Rich. And I'm going to mispronounce his name. I believe it's 𝗪𝗀. I'm going to avoid the last name because I, 1, don't have it in front of me, and 2, I'm going to butcher it. And they were going to be talking about the upcoming release of J9.7, and then typically in these episodes, the annual J release episodes, we talk about the beta, which would have been 9.8. That episode, if you are an astute viewer of the channel, you will have seen has been postponed until tentatively May 4th. So we've titled that ArrayCast episode 125. It was because I believe they wanted to put together some demos now that we have the live stream on YouTube. And so we were originally going to do it today. And it wasn't because they don't want to come on. They definitely still want to come on. They're just in preparation mode. So expect tentatively a month from now, we'll have both Henry on and 𝗪𝗀 on to talk about J9.7. So if you were looking forward to that episode, just put that hope on pause, and we will do that interview in a month's time. So we're going to do a different episode today, which we, I guess, kind of chatted about last episode in ArrayCast 122. But before we get to that, we've got 2 announcements, so we'll throw it over to Adam, and we can do those first.
Right, so there are 2 get-togethers, real life, coming up. First, there is the APL Germany spring meeting in Mainz, in sort of western Germany. It is on the 20th to the 21st of April, so it's just coming up very soon. And immediately after that, the week after, is DINA 26. So DINA is Dialog's North American get-together in New York City on the 27th. And the registration for that closes on the 17th. So if you're hearing this live, then that's in 10 days.
Awesome. And if you watch it any time in the next 10 days, you'll still have time to figure out if you can make it, if you're local to New York, or if not, you're able to travel there. Links we'll try and put in the description/show notes. And I don't think I have any announcements. I mean, technically, I'm working on a YouTube video. I tell you, with AI these days, my YouTube videos take way longer because I realize I can do way more. And there's been some interesting interactions between Elias, author of CAP online, and also 𝗔𝗍𝗪, implementer of CBQN. So, I mean, there's a GitHub repo. I'll find it and put it in the link of the discussion. If people want to take a look, it's on the maximum odd binary, so MOB, and it's solvable very simply in 3 characters, a 1 rotate reverse sort, if you have the reverse sort primitive, that is. And anyways, there's going to be, it's almost going to be like a YouTube talk because it's going to be such a long video. I'm thinking about even doing it live, but that's probably too much work. Anyways, if you follow me on the Blue Skies, Mastodons, or Twitters, or any of those, you might have seen some of that interaction. But yeah, we'll look forward to that video coming out on not this channel. This is the ArrayCast channel, which, I don't know, pop the champagne and little confettis. We've crossed the 200 subscriber mark. We're a fifth of our way to the goal. I see on the statistics we get about 800 within the first month, 800 downloads. So we do have at least close to 1,000. So hopefully we can translate that into 1,000 YouTube subscribers. Anyways, we're looking at on the screen what I'm calling the APL Dojo. And we did talk about this in the last episode, right? It wasn't like a month ago. It was ArrayCast episode 122, I think, where there was this idea of concepts, primitives, expressions that exist in array languages, not specifically APL. I'm calling it APL Dojo, but as you can see in the bottom right here, I guess this is confusing. So I'm screen sharing on one monitor, but then I've also got the thing that I'm screen sharing on a different monitor. So I've got to look at this monitor, even though, the screen share is here. And so you can see down here, we've got 6 languages. I do feel really bad that I haven't added K to ArrayBox. The reason that K is not here is that anytime I build one of these AI scaffolded websites, I just have Git submodule the ArrayBox site. So it has all the syntax highlighting, the logos, the input methods. So it's actually pretty easy to spin up these little websites now. And the idea is that we are going to, if you've ever seen the tier lists on YouTube, usually it's S tier, then A, B, C, D, etc. And they'll do like, the tiered list of Pokemons, the tiered list. I just watched one the other day of all the different Harry Potter games in existence, from the Lego Harry Potter to Hogwarts Legacy. And so usually they use like a rainbow of colors. I personally prefer the karate, like dojo, black belt, white belt system. If you saw the last episode on YouTube, you will notice that we are missing a bunch of colors. I've omitted the yellow belt, the orange belt, a couple other belts, mostly because, one, we don't need that level of granularity. We don't need like 18 levels of, levels or grades. And so I just picked my favorite colors. Obviously, white is beginner, black is expert, and then green, blue, and purple are the intermediate levels in between. And so now we just get to have fun for the next 90 minutes or 2 hours or however long this goes. And we can come back to this. You might think, oh, you didn't cover all the primitives, all the expressions. Of course not. We can't do that in 90 minutes, folks. But, we're calling this the APL Dojo. Maybe we'll have the J Dojo, where we're still going to have the existing board, but then we can add primitives that are specific to certain languages. And hopefully at some point when I add NGNK K6, we can come back and add those. Anyway, so thoughts from Adam first before we start throwing up primitives and expressions, questions, thoughts, or can we just hop into this? What do you think?
Well, I mean, this looks promising. I don't know exactly how it works. I haven't seen that yet. I like the colors. They should be safe for people who have color blindness or color vision deficiencies. So that's
well.
nice.
We also have the text. I was thinking that we should. They asked me, "Do you want to keep the text?" And I was like, "Yes," because just in case we've got colorblind. I don't know the full spectrum, but definitely you should hopefully be able to make out the black, purple, blue, green, white. And I guess we should try to keep this audio friendly as much as possible. So the way it works is we've got APL input. So we can start with IOTA. Well, actually, is this the website? I might have not prepared correctly, folks. We got an F11 out of this. This is the website. We need to launch. Actually, I think it already is launched. So if we go to local
can anybody go to that website? And
yes, anybody can go to this, but it's not going to save your stuff to the official website. And so the idea is this is the locally hosted one. And you can see actually, so let's get rid of this because we're going to do this from scratch, is that if we want to make changes on the fly, I have a cursor instance open and we can just say I've tested this minimally, but if we get to the point where we have, a whole row's worth of blue cards or chips, as the app likes to call it, is it going to wrap and create a second line? Probably not. My guess is that it's going to create a horizontal scroll bar. I don't want a horizontal scroll bar, so we could quickly ask and say, hey, make this wrap onto a second line. We may or may not get there, but the point being is that this is local, so we can potentially make changes on the fly. Madeline in the chat is saying this is going to be the most rage-inducing ArrayCast episode ever. Well, I'm not sure if you mean because we're going to be arguing over what category things go in, or because the audio listener is going to have absolutely no idea what we're doing right now. But anyways, if we want to add IOTA, we can type backtick I. We can name this because you pointed out, Adam, it might be nice to have the name of this. You can choose the rank. So currently it's
probably called range, right? A range generator or index generator, because IOTA is just a symbol name.
Well, so here's the thing. We'll put range in parentheses. I have a soft place in my heart for IOTA. And it's, if we have a little bit of editorial control here, IOTA shall remain named IOTA as far as this app is concerned. But I do agree, range is the better name for this. From a non-emotional point of view. So we'll put range in parentheses. And we will... go ahead.
Actually, Rubenberg or Madeline has already sort of given names to all the primitives across all the various APL languages in the Omnibar. So shout out to that. And there's something we could pull on as well.
Oh, yeah. Should we open up Omnibar here?
I think so.
And then I can just tab through... We go omni. I was just on it the other day. And
You
so I guess
might want to clear everything. I'm not sure if you're. Yeah, that's fine.
so if we search iota, or is it gonna
Yeah, it found it. It found it, right?
Did
But it says it calls it index generator or range, right? Which is fine.
Although, so how do you get it to? Okay, so clearly I don't use this enough. So like, you know how in Google Translate you can search by the name and then click and it'll show you everything else with the same definition but a different name?
Yeah, it doesn't do that.
It doesn't do that here? Or am I just not showing BQN? Show one hidden language. Yeah, there we go. That's what I was expecting.
Oh, that's what you meant. Okay.
Is that I wanted to see the alternative glyph. So a better example for this, if we go table, this is one of the most, what's the word?
Disagreeing.
Yeah, like disagreeing, bifurcating, non-uniformly, not so much named. Most languages either call this table or outer product, but in terms of the symbol, it's got a bajillion symbols. Which is, it's nice from a kind of historical, anthropological or archaeological point of view. But from a learnability point of view, it's kind of sad. I love this little table thing. And so, let's do that. Let's do iota and table as our first two. And so if we go back to our little thing here, we'll just, Adam mentioned that I should add rank because technically, we've got different behaviors across ranks. So we just want our rank 0 iota. This is a primitive. It's a monadic function. So we go create, and then we get this little thing. And then, except I messed it up. We want to go all because even though they've got different symbols, the Unicode character is not supposed to be representative of what the language chooses as a symbol. It's just, look, there's a little bug there. But that should be fixed once we drop it. And so I would say that this is a beginner level primitive or concept. Then the question is do you agree?
Well, it depends a little bit on what kind of scale we are, because you could probably say that plus is even simpler in a way, but you could also say plus is more complicated depending on what kind of arguments you give it. And so do we even look at things like basic mathematics, or do we just ignore that?
Okay, well now we have to redo this because like I said, I minimally tested this, but now iota, all, create. Okay, so there are the little language logos at the bottom. And then I should be, when you click on it, it should give you an update. For some reason, it just didn't do that. So repeat what you just said because I was a little bit concerned that this whole thing was going to fall apart. You said, Are we defining this just for arithmetic?
Are we defining this for should we say interesting functions, right? That do sort of array manipulation, generation things. Otherwise, there are certain structural functions or mathematical functions that are super, super simple, right? That are even simpler than this. So I agree that when I teach APL to somebody, then the index generator function comes in very early on generally. But that doesn't mean that there aren't other functions that are even simpler. For example, you could argue that the right tag, the right identity function, right, is the simplest function that is even theoretically possible. Right? It takes an argument, returns it. Nothing done. There's nothing to understand. A lot of people have problems understanding it because it's too simple. They think it's got to do something, but it doesn't.
So yeah, I guess that's a good point to clarify. There's no, or at least the design of this, when I designed it, there's not supposed to be any kind of ordering of simplicity here. It's not like we're reaching for the simplest idea. We can do that if we want, but the order that these show up, and I'm not even actually sure. So I mean, if you want to, you're calling this, what is it, right tack? And what do we call this? Identity?
Well, it's monadic, dyadic. So monadic identity function, or it's officially called same. I want to change that, but that's irrelevant.
And I think all the languages have this.
Well, so maybe not 𝗲𝗏, because maybe it might not make sense in 𝗲𝗏, right?
I mean, 𝗲𝗏 does have a monadic identity. Well, they don't have they don't have ambivalence, but they definitely do have identity in the 𝗏. So like I said, it uses a different thing. So if we go create for this, we can drag it. And so, I mean, can we rearrange them? I mean, it doesn't look like it. I mean, technically we could do this, right? Oh, actually, what's going on here? Is it possible to get the tack on the left? There we go. What?
Nope.
It doesn't like it. It doesn't like it. So I don't know what sorting is using here. But the point being is, it's supposed to just be like the level
Yeah, so
of
we would not have it. Yeah, I see. Or at least the concept of a density. So that's the thing. Which one is simpler? A monetic identity function or a range generator, where you have to think about like inclusive start, exclusive start, and end, and index origin. There's a lot more to understand and know with a range generator than there is for an identity function, right?
I would agree, but to be honest, like that's the thing is your brain is always operating in like the most complex, fully formed version of like every primitive, which is something I've realized, right? Like if we go to ArrayBox, and I was just mentioning the one rotate reverse sort. So if we go, I actually don't know how to type rotate now that I think about it. And then I think it's 4. Or yeah, there we go. And that, and then we do this, and so, what was I about to show here? Oh right, is that if you click on this, so it shows you, do you want the monadic or dyadic definition of the function, and then it has the same concept of rank. And what I've realized too is that when you go to dyadic, you've got 2 arguments, so you have to consider the rank of 2 different arguments. And like to be honest, I have never in my, what's 2019, 7 years-ish of array programming, ever thought about like the rank of arguments when using a dyadic function. Like a lot of the dyadic functions are pervasive or scalar, so you don't need to think about it, unless if like you've got a vector and a matrix, and then what are you doing? But honestly, that's typically you've got a scalar and then some arbitrarily ranked array.
For rotate in APL, let's say, for example, something similar to what you've been doing lately. Let's say you have a matrix of text lines and you want to center them or right justify them, something like that. So you want to do a separate rotate on every line. Now, in languages that are leading axis originally, like J and BQN, there you would have to use the rank operator to do that. But APL traditionally is not like that. So therefore, it defines vector left argument with matrix right argument on a last axis rotate to automatically pair up a rank 0, 1. So every element on the left argument will rotate 1 row of the right argument. And similarly, you can use the first axis. It's not really first axis then. It's really column-wise, right? So then if you do the circle horizontal bar rotate with a vector left argument and a matrix right argument, then it rotates the columns individually, which would be complicated to do in the other languages that are strictly first axis. You would have to transpose first and then do a rotate rank 0, 1 and then transpose back again. So there's a lot more nuance to this than,
I mean, let's take a little mini tangent in our, we barely even got 2 primitives up on the board, folks, and we're already in tangent land. I mean, what is your thought on the complex? Because I've realized that like dyadic functions are so complicated, in a certain sense, if you start to think about them in like the rank of both arguments. Because like a lot of times when I'm working with these languages, I like I say, I am thinking in rank 1 land or like rank 0 land. Like when I think of the without glyph, I've never thought about a without on anything other than a rank 1 left and right argument. It's just like that's. And maybe without, if you've got a rank 0, like just a scalar, like that makes sense. But like I've never thought about it in matrix land or like rank 3 plus land.
It doesn't, but it should. And it does go by major cells. So that's another thing. That's that leading axis orientation thing where everything that applies to the individual elements of a vector really also apply to the major cells of any rank array. And then for the dyadic ones, then they have to have some ad hoc rules that sort of say, okay, we have to decide on the rank of the major cells combined of the right and left argument. So for example, for a lookup, you want to treat a higher rank array as in the lookup table, and then one lower rank array on what you're looking for. You would treat that as a single major cell of the higher rank one. So for example, you can look for a vector in a matrix, means you're looking for a row. Right? If you're looking for a matrix in a matrix, you're looking for individual rows. But you can't just generalize it like that. And there are some complicated things. So J makes it very explicit in this documentation what the function rank is. and that means it defines behavior on the smallest possible rank, and then if you give it arguments that have a higher rank than that, then it just runs a loop. Basically, it just applies to cells of that rank that the array can handle. So as an example of this is matrix division, matrix inversion operates on matrices. Obviously, if you give it higher rank arrays, then we'll just go to the individual rank 2 cells.
I see. So that's what function rank means in J. It's come up a couple times, and I think every time I've either been confused silently or I vocally said I've never really understood function rank in J. Function rank in J
that's all it
is a primitive being assigned, basically like and that's what I've done here a little bit. Is that like you can see in the top right, I'm defining like what is the most common, defined by me half the time when it was done explicitly, and then Claude 4.6 Opus when it are the primitives I didn't look at. So if you add to this list iota, I think this is for oh, look at that. It calls it index generator. Like I said, the AI was responsible for getting all this stuff, but I made sure that it gave index generator like its most, I don't know what you call it, the default rank or the function rank, but it's the one that you most commonly use in my experience.
Yeah.
And then if you add like in one of the ones when it was I think mix and split, mix is typically on a nested list.
Yeah.
And then split is typically on a matrix. Like in my experience, I'm not saying that these are representative of all array language programmers everywhere. But when I'm building this tool for myself and then other people that want to use it, you end up with this kind of like, oh yeah, some operations you use across ranks, but others you're typically reaching for a single rank, and I guess that is what J has tried to do. They choose a rank, and then they loop.
Well, I think at the time of definition of the primitive, they would have looked for the highest rank that they could have some kind of unique behavior, and then set the rank there. And that's actually in a way sad, because that prevents further extension in the future. So for example, with the matrix division, right? So dialog APL, or I think all APLs possibly, they don't have the rank 2 set for matrix inversion. If you try to invert something higher rank than that, it will just error. Maybe one day somebody will come up with some ingenious insight that will be the multi-dimensional or many-dimensional equivalent of inversion, right? Something that is to a hyper matrix, right? A cube or higher, what inversion is to a matrix. And in that day that happens, APL will just go, okay, well, we'll add that algorithm and the primitive is extended and all good. And J will go add another dot to their primitive, right? To make a new primitive, because the matrix division, matrix inversion primitive is already defined to loop over rank 2 subarrays. And there's nothing you can do. You cannot use any sort of inverse rank operator to tell it to, no, I don't want to look at rank 2. Broaden your scope. Look higher. You can't. So it's a gunner. It's fully defined. You can never again extend it.
Yeah, interesting trade-offs.
So it saves you some rank operators that you don't have to explicitly loop over things. That might also make it more obscure what's actually happening. That's the cost, of course. But then again, you could say that about arithmetic functions being scalar in nature, right? That not having a loop like you do in most languages makes it maybe more obscure what's happening. But on the other hand, you're able to extend things. So
yeah,
you could say, like, as an example of something that could happen, but obviously didn't historically. You could define multiplication on scalars. And like nobody could think of what they would do on vectors, so we just define it as rank 0. And then somebody comes up with the idea of a vector multiply, right, in the product thing, and then you want to extend it, you can't because you already overloaded it to all higher rank arrays by automatic looping. And we don't want to do that. Experience has shown that for array programmers, that's not what we want. But that's kind of concept that it could happen.
Right. Okay, well, I mean,
yeah. There are cases where this is where things are weird. If you try to just extend them with rank, for example, if let's say we're dealing with the range generator. Right? There are different ways you could extend the range generator to a long right argument. So the way Dialog does it, and I think most APLs do it, is that they say, okay, it generates the indices of an array of a certain shape. So if you say 2 by 3, then you get a nested 2 by 3 array where every element has a vector, 2-element vector, that is the enumeration of the indices of all those elements. Right, like exactly like what you're showing now, iota 2, 3. J defines it differently. It defines it as filling a 2 by 3 array with the range of the product of the right argument. Right? There's a third definition you could have done, and then you could say, oh, range. Imagine if they had back in flat APL land when there was no nested arrays, if they had thought, there doesn't make any sense to do the range of more than one number, so we'll just define it as rank 0. Right? That would mean that if you do the range of 2, 3, you'd get a rank 2 array. Then the first row is the range of 2, and the second one the range of 3. But that means it has to pad it. Yeah. So if you do range rank 0 here, no, not each. It has to be rank 0. So just the citation 0, and you have to put a right square bracket to separate the strand. See, then you would get this result where the first row of, so this is range rank 0 on the array 2, 3, is 0, 1, 0 in the first row, and then 0, 1, 2. Right? And they might have said, okay, it's maybe not the most useful, maybe sometimes you want this, and it's fine. They just pad with zeros. Maybe it's good for like making triangles and things. This would allow you, for example, if you now write, instead of 2, 3, if you write iota 5, or I.5 in J, so now you get a nice triangle-y type thing, right? Maybe that would be useful. And then somebody comes and say, hey, no, you could do this instead. We could make it fill a 2 by 3 array with the numbers from 0 to 6 or to 5. Or in the APL land, we said, oh, we could make it nested because now we invented nested arrays. It's too bad. Ship has sailed. Anyway, that was a tangent a bit. You're absolutely right that when we can't just make a list of primitives because the pairing of left and right rank, or even left and right nesting level, and monadic form as well, in nesting level and rank and so on. Sometimes even type, like in K, you get Q land, you have like type overloads as well.
Yeah. This is what I was just talking with Madeline, who's also in the chat right now, on the last Tacit Talk, is this realization that we always hear about rank polymorphism in array languages, but you never explicitly hear about ad hoc polymorphism. And on top of that, like, there's multiple kinds. You're overloading on the rank of your argument.
Your polymorphism, type polymorphism, even value polymorphism, I would say. So if you go to say Dialog APL and you do $5, you get a random number from between 1 and 5. But if you change, and any positive integer there will give you that same sort of result. But if you change to a 0 instead, it's actually a different function. It doesn't generate a value in the range from of the first 0 natural numbers. Rather, it gives you a float between 0 and 1, which is actually something completely different. So that's type overloading. Right? There's no rank polymorphism here that's different between those two cases. There's no depth polymorphism that's different. An example of the depth making a difference is, I believe in the from or select or whatever it's called function in J. Then you for every dimension you can give it a list of the sort of the indices along that dimension that you want to pick out. But if you enclose that one of those elements, it means all enumerations along that dimension except these. So the depth, just at adding an enclose, changing the functionality completely. So to being, instead of select these, it means deselect these. So what do you call that? That's depth overloading.
Definitely,
right?
it's a type of ad hoc polymorphism, but yeah,
Sure, but then you could call anything ad hoc polymorphism.
Well, I mean, that's
right?
the thing is
You
ad
can
hoc
come up with a
polymorphism
fact-
is ad hoc, right? It's when you
Yeah.
define separate behaviors based on different things: number of arguments, type of the arguments, depth of the arguments. That's why it's called ad hoc, because it's just kind of like we could inject different behavior in here based on something, right?
And if you go with an APL2, then the slash is either replicate or reduce, and it's always an operator. And the type of the operand, it's a monadic operator, the type of the operand determines the functionality. What is that then? Type overloading, two different primitives, the same primitive. And you really have that as well in some dialog operators, right? The power operator, the asterisk with 2 dots on top. If you give it a function right operand, then it means until that function returns true when evaluated with the arguments of the previous and the current iteration. If you give it a value and an array, which has to be a scalar number, then it repeats, right? So it's repeat and until, which are related concepts, but definitely not the same. Repeat is a fixed bound, and until could run forever. We don't know.
Yeah.
So here again, it's the type of the operand. So if you go back to the dojo, things will get a lot more complicated if you don't have nearly enough selectors on the right. Right? Because what if you want to do something like reduce? So
all right, let's try. First of all,
so which one?
This is not. So this is a
It's
one modifier.
Okay.
So we lose our ranks, which is
but hold on. So which derived function in APL, dialog APL at least, the dyadic derived function is windowed reduce, but the monadic derived function is just normal reduce. But if you try to select monadic dyadic function up here, then you lose the selection of the one modifier. So those are not exclusive.
Well, if I do,
it's not an expression either. It's a derived function. So you need to.
But
disconnect
technically, if we
right?
call it an expression, I can choose, this to have just the reduced meaning. We choose it as APL, and we choose all of this. And when we create this, this will basically, it'll syntax highlight it as, so technically this is, well, so I guess actually what the real thing to do is, if we get rid of this, we want a primitive, and we want to be able to select one modifier, but when you select one or two modifier, it should give you the option to say what you want
function,
the arity
or ambivalent function. Because sometimes it's nice to treat them together. For example, for the dojo here, we might want like functions derived from key or anything derived from key, right? That might want to treat that separately, but sometimes you would want to treat both the monadic and dyadic form, things like constructs with add or something, where it doesn't really matter if it's monadic, dyadic, the power operator and so on. And there it's not important, so you should be able to leave that out. But what you could do here is actually internally in dialog and in APL2 as well, I think the other APLs, if you ask the system for the attributes of an entity you have, then it will tell you the valence. So, and that's also something that's missing over here. You have subtype, you've written monadic function, dyadic function, but there's also in principle niladic, right? So for example, 𝗔𝗿𝗏𝗆, right? That's a sort of a niladic function, returns a constant value if you want, or you could see it as an actual array. That's up to you. So we use numbers, and you can query these numbers for any given name. You say, what is the function valence? And that can be 0, 1, or 2. And it can be ambivalent, which is designated -2, but that's just to have some number that you can refer to. And then there is what is the operator valence? And that's also 0, 1, or 2, where 0 means not an operator. 1 means as you write, 1 modifier, 2 means a 2 modifier, or monadic dyadic operator. So those two numbers, the function valence and the operator valence, those completely describe the what should I say, the syntactic role of any given thing.
Are you saying? Well, I got a little bit confused. Are you saying that because one modifiers don't have the ability to accept different arity, or in your parlance, valence functions, right? Like a reduction.
True, but that's not the point. It's the function valence of a construct using in an operator would be referring to the derived function. So, for example, plus slash.
Oh, I see. What you meant there was not the argument; it was the derived function.
Yeah.
Okay.
Yeah, the derived function.
I mean, definitely we should add that. So let's go. Which one of my cursor implementations? Okay, so if we say for the 1 modifier and 2 modifier.
You just need to split that, right? So the subtype that we have here, there should just be 3 options for each row, and there should be not 1 radio button group, should be 2 groups.
Oh, you're saying don't have a new section that is enabled by click, because I was thinking if you click either 1 modifier or 2 modifier, it'll pop up a new section that says like derived arity. I mean, but you're saying just have like
any reason for that. Yeah, just instead of a subtype, you have one that's called function valence, and then a new section called operator valence, right? And then the first option in operator valence is not an operator, right? On NA or whatever you want to call it, right? And the first option under function valence is
no. I like my idea better, because the having to click not applicable is anyway. So
that can be the default, right? It'll be 0.
Add a section,
but that's up to you.
Called what do we want to call it? Derived function.
Yeah, derived valence or derived.
Should I switch to valence? I mean, I like arity, even though I prefer monadic and dyadic, and I know arity goes with unary and binary, and valence goes with dyadic and monadic. But I don't know. I guess if you're listening to episode 123 of Arraycast, you probably are able to interchange between arity and valence.
I think Marshall had a very good point. It's like, keep simple language. Just so you call it the 1 modifier, 2 modifier. Why not, instead of subtype, monadic function, dyadic function, you just say 1 argument, 2 argument, right? And then 1 modifier, 2 modifier. That's all it means. And then 0 argument means it's something that's like tilde or hash or those things, null, or just numbers. Right?
Why use monadic and dyadic? I guess because 1 argument and 2 argument to my ear sounds this is the incorrect word, but the word that popped into my head was like Neanderthalish. Like it is, you're describing.
That's great. Much easier to understand.
Yeah, you're describing something in simpler vocabulary, but something that has a word that was specifically designed for it, and it's kind of like Trumpy, like Trump says, we've got big, beautiful books, and he says 1-syllable words to make it understandable to more people. But it's like, well, there is a word for that we have called unary, binary, monadic, dyadic. But I guess why
I started doing this in the APL challenge that we have going, where I've started simplifying the way we describe things. Both the names for things, like we experts like using long, complicated sounding words to make them sound more intelligent or more educated than the masses, even though it's just simple concepts.
Yeah, that's true. I mean, there's pros and cons, right? One argument, like I definitely, when I'm giving talks, and whenever I first say the words unary and binary or monadic and dyadic, I always add a little explainer like FYI, and sometimes I'll even show the Wikipedia table of the Greek words and the Latin words for unary, binary, ternary, quaternary, and monadic, dyadic, tetradic, and quadratic. And then people probably go, oh, okay, yeah, that makes sense. Because I definitely remember being confused the first time I heard the word binary and didn't realize they were talking about arity or valence. But anyways, let's we'll put maybe I'll rename this stuff, but let's I'm still halfway writing the prompt.
That's a minor thing.
Add a border with the color for the modifiers similar to expression. I didn't really explain this well, so I mean, if the AI understands what I want, That'll be very impressive.
It will understand something.
Well, I mean, it'll understand something, but will it understand what I wanted? Maybe, maybe not. So what I'm hoping is that there'll be a new section called derived function arity, and then it only shows up if one or two modifiers selected. And then, so if you add a slash, and we call this reduce, and so technically we're talking about the monadic derived case here. Which I believe all the languages have. The dyadic derived differs. But if we do this, it should create me a yellow. And note here at the bottom, I haven't mentioned this. So I'm using the 𝗦𝗛𝗢 syntax highlighting, which differentiates between monadic and dyadic functions, which we can do in 𝗦𝗛𝗢 because we have no ambivalence. We've got fixed arity.
Yeah, that's good for this purpose here. Right?
Yeah.
I do that in Apple Card as well, differentiating entirely between monadic and dyadic functions.
I do give the option, though, underneath, because people are going to get confused if they start seeing, because technically a one modifier in most of the array languages is syntax highlighted green. So if you want, you can switch and then make all the functions blue, just so people don't get confused. And what should this be? A green? Blue?
Reduce? I mean, again, it depends. In the basic form where the operand is a scalar function, then it's green is fine. But if the operand is not a scalar function, then it's interesting. And I would even say you could even go further. What kind of reduce? Plus reduce, times reduce? Sure. Those are very simple. Everybody gets those. Maybe those are even white, even if they're a bit of special syntax. But unequal reduce, which is an XOR checksum? Maybe not. What about left tag and right tag reduce? That selects the first and the last elements. Are they as simple? And then you have things like custom function reduce. I do that sometimes. We want to run the same function on an original data and then with varying left arguments. So you take all the left arguments, concatenate them to the enclose of the original data, and then apply reduce with some giant custom function. That's a whole different technique.
All right, let's pause you there because this is fantastic. This is what I'm talking about, folks. This is what the APL Dojo is all about. Well, first of all, we're going to hit F5, see if the AI did what we wanted. We're going to hit this. It doesn't seem to... Well, what if we...
Did you reload it?
I did reload it. I don't want to hit Control F5 because that could potentially release. But if we...
There's another thing that's missing here, I think, is on the type. You've got primitive expression concept, and I would also add technique as another one. That's neither really an expression nor is the concept. But as we'll get to eventually on the black belt, is dual wielding rank operator with two different ranks for the left and right argument. That's a technique. It's not an expression. It's not a primitive. It's not a concept.
All right, we'll add the technique for next time. So the AI...
I think we can start a new podcast, the APL Dojo podcast.
Well, this is all we do.
This is all we do.
Well, so actually, while we're waiting for the AI to fix what it failed to do, let's add the not equal to, because I actually had this as one of the expressions when I was sending you screenshots. So this is an expression. It is a monadic...
It's not an expression. I guess you could call it an expression. It's a derived function, but yeah, okay. Yeah, it's an expression.
Anything that's more than a primitive, but less than something that needs to be described by words. And then we can highlight it as APL. Do all of the... I think all the languages have it. So we go create. And so this one, you can see, has a gray background. And what is this? Is this blue? Purple? I don't think it's black belt. But
no, not more than blue, I would say.
All right.
It's not that hard to understand.
And so you can see
there's also the scan equivalent, right? That one is more interesting.
Yeah. Actually, that's the one that I was thinking about. That's what I was thinking about. So let's add that one as well. And actually, wait. The AI says it's done. Let's hit F5. and see what happens. So now we go here. Why? What is going on
Nothing
here? It
happens.
says, I mean, it's so sad. You spend so much time working with these tools, and it does everything perfectly.
I think we might be running out of belts very soon, because I think we'll be able to identify things that are definitely easier than one of them, but harder than another one, and fits in between. Madeline wrote in the chat that she thinks a reasonable split is associative scalar or other, and then on vector or higher rank. And it's probably especially like reduce first would be higher, difficult, or different than the higher rank. So yeah, think about it. Where would you put plus slash? Like monadic plus slash, the sum. On green, right?
Yeah, I mean, I would say, and that's the tricky part, is when you were breaking down all the different reduces, is that there are more complicated reduces, like the not equal to reduce, and the left tack, right tack, and the custom ones, and the non-scalar ones. But like when I see just the reduce, in my mind, it kind of categorizes it as like the simplest version. So like plus reduce fits in here, multiplication reduce fits in here.
But it stops there, right? Because as soon as you go to minus reduce, things get real fun. Like that's an alternating sum. And division.
It depends
reduce
on your implementation.
further.
Only APL has the
exactly.
alternating, and then other ones do not, right? Like BQN doesn't have that.
So the plus slash in APL is different from the plus, the tiny little slash.
And that's why we've got the languages. So when as soon as it's different, you start tagging them. But like honestly, like that's the problem, is that in my mind you do all right. Let's hit F5 again. I sent them a screenshot, so.
What happened?
I mean, what's going on here?
Should
I risk hitting Control F5?
You're gonna lose all of your.
Yeah, well, it didn't lose.
How does it? I don't know how it's stored.
There we go. It was a hard refresh problem.
Cached. Should blame caching.
So now this is monadic, and if I update it, now it shows that this. And so technically,
nice.
If we want, we can do what you were talking about earlier. And so for this, so BQN doesn't have. So I'm thinking about the n-wise reduction. So J.
But see, there's a difference as well. Here's a value difference.
There's always a difference, man. That's the problem. Is you're operating up here, and I'm just like, let's just add this, and you're like, no. There's six different things.
Connor, if you do a two-wise unequal reduce, that is a very simple concept. That's just comparing adjacent elements to see where do we have edges, right? Where do we switch from one value to another value? Mm-hmm. But anything more than a 2 as left argument, that means you're actually doing XOR reduces over windows, which is right.
Well, I mean, so in my mind, it was just going to be this. It was going to be, once again, this is a one modifier, but dyadic derived arity, primitive. We can even call this n-wise reduce. BQN doesn't have it because they use the left argument as an initial value.
J doesn't have it either, right?
J doesn't have it. 𝗍𝗏 has folds and reduces, and I definitely don't think 𝗍𝗏 doesn't build it in here. Cap I know has it, and I think TinyApple has it as well. So we create this. Now you get one with the green border. I would add this.
Not the prettiest thing.
Yeah, it's a little bit hard, but it's something. It's something. And and also too, it's a little bit. I should add like a black.
I would say there's a big difference between the 2-wise reduce and n-wise reduce. 2-wise reduce is something so simple that even K has it as a standalone operator, right?
Yeah, that's prior, right?
Prior, exactly. Oh, by the way, Madeline says TinyApple doesn't have that reduces is int_ly value.
Well, then be gone, TinyApple.
Yeah. So I think there's a big difference there, right? Between what do you like if we go to C++ land, right? Adjacent differences is called, and doing windowed things.
Yeah, adjacent difference in C++ 98 is just that, but the generic adjacent transform that showed up in C++ 23, that takes a static argument, a template argument that can be anything. So it's
Right.
it's like the n-wise reduction. So I mean, but like, how do we? So if you want to delineate these, technically the way to do it would be, it's technically well. I don't actually know. So
How
I
does
mean,
that work, by the way? When you click the ADIC function there
you know what we
on the
should have?
subtype?
We should have like the cross. Like the we should get the symbol. The two different crosses. One's like Henry's and one's, I don't know, some other guy's names.
Yeah.
And we should like, that's not a symbol in any of the array languages. So that should just be for a generic binary operator, so that we can put
How's that not a multiplication symbol?
Well, because multiplication is actually a thing, right?
Yeah, but that's the other cross you're talking about, right?
Yeah. Anyways, but I'm just saying we need one of those symbols. Like in mathematical, like academic papers, they use that for.
They usually use a blob or something.
Yeah. Well, we need something because op looks bad.
Star.
Right?
So
all of these are taken, and question mark, it means something.
Yeah,
but
you want the solid blob.
Well,
The
actually,
one that's filled.
we can just go get
Yeah.
that.
Yeah.
Where? Let me. I need another. Let's Google.
It's just a black circle, right?
Generic binary operator cross Unicode.
It's not cross.
Actually, what do you?
What I've seen in mathematical papers are two different things. One is a star, and then there's the those that use just a filled black circle, a blob.
I'm on Shape Catcher right now, on a different monitor.
That's a bad thing for you, filled out things. You have to fill it by hand.
Man, I just got a bunch of clocks. What the hell? Here, actually, people might.
Yeah, because you're trying to fill it. That's the problem. I can give you the Unicode value if you want. You have U plus 25CF.
What?
Yeah, never mind that. Just get U plus 25CF.
U plus 25CF?
F, yeah.
That's not the one I want.
No, so I don't know what you want.
I want the cross one.
Well, which cross? The dagger symbol?
No. There's two. There's Henry's cross.
Oh, you want the circled ones?
Yeah.
Oh, that's one. I mean, even that's sort of.
Come on, what's going on here? Is this?
Yeah, there's. No, that's a weird letter. I can also.
Old italic letter the. I mean, this looks pretty close, but.
That's not what you want. You want the one with a. Now I understand what it is you're after. Here, there are a couple of different ones. It's NRE circled operator, it's called, or circled plus, if you want.
Circle. I mean, actually, I should have been able to guess that. Circle plus.
It is. It's U plus 2295.
U plus 2295. He says.
Yeah.
There we go. Now we're gonna.
You should have just told me what it was you wanted.
Well,
Or you could have asked an LLM. Who knows?
That's true.
You could.
There we go.
The whole thing.
All right, I'll keep that in my copy buffer and make sure not to.
Roger Huey and I suggested giving that meaning in APL, but yeah, and I believe it's actually a function in Tiny APL, possibly.
So now we create this, and you're saying this is simple? This should be here? I don't know.
Yeah, no, that should be. Yeah, I don't know. I guess.
And then you're just saying like n. And this is.
So just know that in Tiny APL, this is a function that Roger Huey and I proposed.
So does that mean we get rid of the n-wise reduce here? Like, what's a better way? Like.
Yeah, I think that's much clearer. Now you can see what it means. Otherwise, I can't tell the difference other than by color, the difference between that n-wise reduced and the normal reduced on there.
So get rid of this one, the one that I'm the colored yellow one, and then just keep the expressions is what you're saying.
Yeah, I think so. It's much clearer at a glance what it means. I mean, what I would do in say Apple Card is I put an F.
An F for the n, or an F for the symbol?
No, for the generic function, because it's not necessarily a primitive. This sort of indicates it's a primitive. It could be any function.
Well, it's supposed to just mean binary operation. Is what it's supposed to mean. So, I mean, for the audio listener that hasn't switched over to YouTube, big mistake. We have been trying to figure out how to separate the variations or variants of the n-wise reduce. So Adam, I'm sure you understood earlier, was saying that a 2-wise reduction is much simpler than an n-wise, where n is greater than 2. And I guess, yeah, that's actually not... Technically, n could be 2 here, but hopefully the fact that both of them are on the screen, people can deduce that...
Yeah, that's fine. Otherwise, it'll be too complicated. But see, what I would do here, you have another problem, right? Which is the rank that's not steady here, that you're going to put in the little circle in the corner. That also makes a difference. So here, this is last. If you're doing APL, this is last axis reduced. But first axis reduced would probably move up one level, right? Because then you have to understand how it works along the columns.
So you're just saying just the first axis reduction? And we
that's first axis reduce. First axis, all of the first axis reduces are like one level up, sort of from their equivalent last axis reduces. It's easier to understand the last axis reduces.
Oh man, it's so confusing.
Yeah, but that means we have so many levels. So what I do, instead of all these colors and the settings and things you have to do, what I do in say Apple Card and the other Apple Card inspired things do the same thing, I believe. That is to use codes, right? So here, if you go down to like the iota one, right, that says iota will rank 0, then I would write that as an expression. I would write iota m, uppercase M, lowercase s. That means, so m means a right argument that is numeric, n. So uppercase N, lowercase s. That means a numeric scalar. And then if you want a vector, you write NV, numeric vector. And then at a glance, you can see what it means. And so too with a function. So you could also introduce things like fs for scalar function or fm for mixed function, things like that. So I use text codes that don't rely on coloring, don't rely on like little icons and things. That's different stuff. Anyway. This is hard, right?
It is very hard. It's ruining the fun of APL Dojo. There's too much nuance.
So sorry. Yeah. So now we are up to the purple belt on n-wise reduce, right? On a primitive. But would you not say that there are concepts and primitives and so on that are like leagues above that?
Yeah. So you're saying we need more colors?
Maybe. Or we need to revise our strategy here, because that's what I'm saying. This is hard. Where do you
that's something the AI is not going to mess up. We can add back a couple colors. Although it's going to have to choose a red, because I gave it an image and it chose the colors perfectly based off that image. But now it's just going to have to make up a red, which may or may not choose a red I like or a brown I like.
I'm not sure it's a good idea, because at what point does it not become useful, right? Well, we could also do a sort order. Like an absolute ordering, or like a total ordering of primitives and concepts and everything. Is like, what is harder than what? And then you can choose your cutoffs arbitrarily, and then you get your belts. Madeline saying in the chat that first axis reduce is simpler than last axis reduce, because if you explain leading axis concepts early, but that's not true. That is true in a proper leading axis language, but in traditional APL, leading axis reduce is not actually a full leading axis primitive dealing with higher rank cells. Instead, it does some sort of interesting thing along the columns, or along it splits up the array into slices along the first coordinate and then applies things. Well, is it? Well, it says APL Dojo. Madeline's protesting it. It's a general array language dojo, and I don't know. I think it will be incredibly difficult to do all of this, and also have all the different nuances across languages in mind. There's already so much nuance just for one language. And
I guess here's the question: is it possible to do this nuance less, modulo nuance? Like, is it possible to just kind of discard because like in general, you know, we don't need to split 2-wise reduction and n-wise reduction. Like, and I guess that's the problem, is depending on how you learn these languages, what your background is, how you're coming at it. You know, I technically, when I discovered n-wise reductions, I had seen the 2 comma slash, and I just thought that was an idiom. I didn't realize you could replace the comma with like any operation. And the day I realized that, I was like, holy smokes, that's amazing. And so really, like when comma is your operation, a 2, a 3, a 4, it doesn't really make a difference. And so then when you realize you can place it with a binary operation, or and then it just does a reduction equivalent basically on it, to me they're the same thing. So it's like people are gonna, if Madeline thinks that reduce first is simpler, because of her path, and I think NYs and 2Ys go together. The question is like, are we able, like, dyadic transpose? That's what we mentioned at one point. This is a dyadic function, and we're just going to put, I believe that's that. We call this dyadic transpose. And how many languages have dyadic transpose? I don't know, because I never use it. APL?
I suppose all of them have. But they're not defined the same way.
That's all right. That's what I mean. Nuanced
so
list.
yeah. So you can
is it easy enough to just do that, and like or do we have to say that they're all?
What are we trying to achieve? What's the goal of this?
I don't know. I think the goal of this is to, at a high level, put primitives, idioms in the form of expressions, and high level concepts in these different categories, so that if you are in general at like the blue belt level, you can look at what is above your level of knowledge and find the missing, tools and concepts and ideas, and be like, oh, okay, like, and double rank. Is that a concept?
No, it's a technique.
It's a technique. All right. Well, we don't have technique for now, so we'll just call. And I guess can I? Oh, look at that! I can. The input method still works here. And so is double rank, is that a thing for all the languages as well? This is something that I never do as well. So like I'm out of my depth here.
And any language that has the rank operator can do double rank.
And
it's just taking double rank is not a built-in thing. It just means you took a function that's derived from the rank operator and you applied it with the rank operator.
Does 𝗲𝗏 have rank?
It has planets, right?
We'll leave a 𝗲𝗏. So if I do this, and then I just put double rank up here,
Yeah, that works.
And so
but hold on. If that's black belt, where do you put single usage of rank?
Yeah, that's a good question. That's what we're here for. That's what the APL Dojo is about.
Yeah, but if single usage of rank is purple, then surely dyadic transpose would go down to purple as well. They sort of belong together in my mind.
Wait, say that again. If single usage of transpose?
Single usage of rank. Of single usage of rank goes down to purple, then I would put dyadic transpose down to purple as well.
You think dyadic transpose and rank are at the same level?
Yeah, I think so.
No. I've never used dyadic transpose once in the 7 years. But that's what I mean. It's different for everybody. I've never used it once, and I don't even know what you use it for. I've heard you and Marshall have the most crazy tennis match of like primitive high-level black belts going back and forth of like, oh, it's a one rotate on the left argument. It's like, oh, it's just a reverse of blah, blah, blah. I still will remember. I don't remember what episode that was, but the rest of the ArrayCast panelists and me were just like baffled. I use rank all the time. I mean, if I need to do something on a row-wise basis or a column-wise basis or something, and especially in J, rank 0 in J is a very common thing. And I don't know, what is that? What is the chat? How many we've got? Max, Madeline, and I guess Adam is the third person right now in the chat. What do Max and Madeline think? Where does rank go?
Madeline's saying that the transpose has nuance, right? That's dyadic transpose has nuance because there's some languages where you can give like a short left argument to transpose, and she says it's simpler to explain how just bringing one axis to the front rather than reordering all the axes. Whereas a different way of coming at it is saying dyadic transpose exists in a simpler version that is less powerful and a more complicated version that's more powerful. And by more complicated, meaning those that can take short left arguments, like a single scalar left argument that Madeline was saying was a simpler thing. I would say that makes the whole primitive more complicated. I'm not saying we shouldn't do it. I think it's a good idea, but But there's so much nuance here. There's like, we're drowning in nuance. I don't know how to do this.
That is the problem. We're drowning in nuance.
So what I have done, really, like for real, something that already exists, is that I always sort the data table in Apple Card by a very simplistic sort. It doesn't even distinguish between any of these nuances at all. Of course, this is only for APL. The only thing it distinguishes between is the character involved. Okay, and I made some sort of, according to my head, arbitrary ordering of primitives, of symbols in APL. And I can show you that, or you can pull it up yourself if you want. And
we're going to Apple Cart?
Well, no, don't go to Apple Cart. Go to Apple Cart source, right, on GitHub.
I can see we can
you can go through and click the GitHub thing. Yeah. And then you go to a file called cars. Okay, cars.apla.
Is it in the top?
Yeah, it's in the root. Yeah. I like to keep my things simple. It's right there in the middle of your screen. It was before you scrolled.
Oh, it's
I think it's not alphabetical order. Oh, it's yeah. Okay, so this is a bit small. You might want to make it bigger. Yeah. So this is my attempt at a rough ordering from simplest on the left to most complicated on the right, where I remove all the nuance, right? There's no consideration of ranks or depths of arguments, no consideration of even the monadic or dyadic form of the primitive, right? But, right? So I'm saying I think it was a space on the left, right? Space is the simplest thing. And then right tag is the simplest function, and left tag is this next to simplest function. It has the slight complication that when you give it a right argument only, it still gives you the right argument. So it makes it more complicated than the right tag, which is pretty obvious. Then plus, removing the nuance that plus deals with complex numbers, right? With complex conjugate, and it is just passed through for non-numbers and so on. So that forgetting that nuance, minus times should be pretty simple, right? And then or and removing the nuance of the number theoretical things, right? Because in the most common case, it's just logical or and. Those are easy to understand. Then round up and maximum, and round down and minimum. Reverse last, reverse first. Notice I do the last axis before the first axis. I think it's easier to understand for most people. Then division, right? Why didn't division go plus minus times division? Because division is a bit more interesting, that you have to learn with the reciprocal sort of. Yeah. So I mean, we had minus there. Then modulus and absolute value. Then we go the factorial, and then choose k, and then we get our the random number function, which it's again in combinatorics, so it's sort of that area. And then we get all the comparisons. I didn't order them by simplicity, right? There's no way I can say that less than is simpler than greater than. So I just put them in the standard order they appear in. And those are scalar comparison functions. So slightly more complicated than scalar comparison functions are the full array comparison functions. And then some structural things. And of course, I would say mix and split are maybe more complicated to deal with than drop and take. But being that they share a symbol, I've got to put them in an order. So that's where they go. Right? And then reshape, because reshape is sort of similar to take, and then we do more advanced math. So all the advanced math comes over here. That's the power, exponential, logarithm, and the circle, all the circular functions. Tilde comes here. You could say it's a simple Boolean function, but it deals with sets also. So I guess I put it here. Then the compositional operators, first the monetic compositional operator, and the binding, so on, and then the more iterative ones. And then reductions and replicate there, right? And we keep going, right? We keep scrolling. Then the NAND and NOR tend to be a bit harder for people to wrap their heads around. Then some of the structural things that deal with combining arrays and opening up and splitting them up and selecting from arrays and lookups and all those kind of lookups and set functions. The power operator is not that complicated. Grade, pretty complicated. But again, if we had nuance, Monetic grade, not so bad. On numbers. Monetic grade on characters, yeah, sure, not so bad if you know about Unicode, things like that.
I can't believe
Monetic,
Scan is so far.
well, yeah, well, but think about what does grade mean on a not simple array, right? On a vector of multidimensional arrays, right? What comes first, a 2x3 array or a 3x2 array of this, otherwise containing the same things? That's pretty complicated. The total array ordering, and then dyadic grade is again has nuance to it, right? The left argument that is a vector, and the left argument that's multidimensional. That's like the multidimensional left argument. That's something Roger Hugh would used to test people if they really know what they're talking about. Then the brackets, and again, I can't say that left or right bracket comes one before another, but they actually do a bunch of different things. So there's a lot of stuff to learn. Transpose, key, right? It gets harder and harder to sort of see exactly what things should be. Then we've got inner product, but that's also dudding into things. So there's a whole bunch of complication there after stencil. Encode, decode, it's all simple when you've got a single number you work on and a single base you're working on. But when you like mixed base, multi-number conversions, it's right up there in some pretty advanced stuff mathematically, especially like encode. So at that point, also more mathematics of domino, right? Matrix division, inversion. Then you got all kinds of systemy stuff, right? That comes over here. Things that are not even like core language things, but they still have glyphs, execute, format, spawn a thread, system calls to the I-beam, the variant thing that changes the behavior of things, input, output, assignments that which behave in the assignment is not just assignments. Like that's like the simplest concept you can have in a programming language. But think about APL assignments. You've got modified assignments, multiple assignments, function assignments, operator assignments, localizing assignments in defense, which you can override depending on what's on the left. Pass-through values, multi-name left side with a function that has an implied each. There's so much stuff to know about assignment. A diamond now fulfills multiple roles, guards in defense and control structures and stuff like that, and what is and function definitions and other things you do in a tradfin and a defin, and hash is for namespace references, and then comes arrays. Now here's not for complication reasons, right? So I put all arrays and identifiers and so on at the end. That's not because they're more complicated. It's because I wanted that sort order in for strategic reasons. In Apple cards, the primitives come before named things. This was my sort of take on a rough, without any nuance, ordering of the dialect primitives. And of course, you'll disagree with it. I can disagree with it. It's sort of rough like that. But sorry, if you now want to give them belts, you have got to put some arbitrary cutoffs between them. Yeah, go for it. No nuance. This is what happens if you get no nuance.
Well,
and this is just for APL, dialog APL specifically. Now you add splitting monetic dyadic, splitting all kinds of overloads, splitting up with argument ranks and depths and values, and multiple array languages. You've got so much nuance. It's like,
well, I mean, before we move on from, Madeline pointed out that the exclamation mark and the I tried to zoom in and
it's a very minor thing, but yes, the distance between the dot and the rest of the symbol in exclamation point and question mark are different. Also, the height of the symbols is a bit different. It's a bit funny. But I would say that the actual problem here is the exclamation point. No, the question marks sort of loopy part is too low. It should just be higher up in general. But hey ho, this is minor. This is very much a tangent.
Yeah, I mean, I'm torn because I really do think that it's possible to have a thing like this, and a thing like this being the APL Dojo, where you've got a nice little tiered ranking, a linear list of this doesn't. I mean, maybe I guess if you want to learn, you can start just by going primitive by primitive by primitive.
But I don't think it's a good idea either, because I like to put my students in APL in a position of being able to do something fun really quickly. So I want to teach them, sure, range generation on it, that's fine. Then I want to teach them maybe some reductions and some arithmetic, and all of a sudden they can now compute things like Pascal triangle type things, and the number of sugar cubes in a pyramid of sugar cubes and things like that. So there's also like, what should you be learning next? And I think I have taken very, very little martial arts. I started going to an Aikido course a long time ago when I was in high school, and I hurt my shoulder and I didn't want to continue. And there's just a couple of lessons, I think. And then I took like a month long, but it wasn't full time. It was like 10 hours a week or something. Course on Balinese martial arts. I don't remember what it was called. So there was nothing about belts, not even getting to any belts or anything. But even there, I would imagine that you would take some more difficult concepts and put together with some simpler moves so that you can actually do something. And if you do all the simplest things, which is wiggle one finger, wiggle the next finger, it gets very boring very quickly. But what this might be able to do is to say, if somebody's struggling, right? They're self-studying APL, and then they're dealing with the 𝗔𝗿𝗢𝗪𝗏 transpose, and they think, why is my brain not catching this? Getting the reassurance that, yeah, this is hard. We know this is hard. Might help.
Yeah. Like I said, fits with the thing of like saying I'm at this level. What are the concepts or things above that I should learn? Like the goal of this isn't like I want to have a certain amount of, like I said, granularity so that you're able to represent.
Yeah.
But I don't know. Maybe the rank is.
Are you aware of the Applecart quiz? You ever seen that?
No.
So try, if you go to Applecart for a moment. So there's a link at the bottom center where you can click on quiz, and there are these 3 different types of quizzes that you can do. Right? It doesn't check your answer or anything. It just lets you in your head try to, or paper, whatever, solve something, and then you can check it to see the result and then continue. But notice the first one of these, which is always writing a function for a given task. It says how difficult it is. It solves the following medium difficulty task. And that, so there you have a sort of granularity of how difficult is the task as a whole. And how did I do that? It's, if I remember right, it's been a long time. It looks at it does a weighted sum, right? So it looks at the primitives necessary to solve this, because it's just using the Applecart table. And then it looks at the position of the symbols in that list that you saw before of the primitives difficulty and sums them up. That means more primitives, more difficult. More primitives that appear further to the right in that list, more difficult. So the simplest thing is to have something on the far left, a single thing from the far left. And then it just grades it into those 3 different levels: easy, medium, and hard. So I did some arbitrary cutoff, probably like the 1/3 and 2/3 cutoffs between the easiest and the hardest, something like that. So there is, I think I agree with you that there's a way that it's possible to say that something is harder than something else, but I'm not sure how much value there is in saying that this is the level you're at. These are the primitives you should study. Sorry, sorry.
I don't know. We're getting
down. Yeah,
we're getting lost in the like. Well, first of all, this is just I mean, it's gray. There's a reason why array box. If we oh, that's not correct. Delete. And we zoom out here. I mean, if we hit F5, got this nice little animation now. You click this. People or I don't know, everyone's different. Maybe some people like gray websites, but I really value logos, color, and the aesthetic of things, It brings me so much joy to hit Control K and then to go Control down and to toggle through all these keyboards. And like color is so important. At least for me, like when I was doing the
Wait, so are you commenting now on the colors in Apple Card rather than that everything is gray? Rather than
I'm just
the actual
saying,
content
if
we were
I'm
talking
trying
about?
to learn something or deal with something, like I go to Arraybox all the time now. I want it to be a pleasant, like visual and like all above. The quiz, it hurts my soul. It looks like something died. It looks like or at least something inside me died. Whereas even if this is less, we got a little color, we got some logos. We got to have logos. That's why K would already be included if K had a logo. And that's the problem is I got to come up with my own logo. I don't want to come up with a logo.
Good thing we got a logo for APL then.
And there was a bug in J that this was not being syntax highlighted correctly. And I realized because this was like blue and this was orange, and I was like, wait, what's going on anyways? So then I went and got and fixed it.
You have to tokenize it. Yeah.
And but that's the thing is it's a lot easier to read J when you've got syntax highlighting of the operators and the functions. And anyways,
I mean, you could have multiple things of the same. We're way off topic from what we discussed before, but even in J, you can have multiple tokens of the same type adjacent to each other, and you can't see the borders. For me, the big problem with J is the tokenization. It just blurs in my mind. Maybe a clever ligature font could fix it to like sort of move the things together so I get a little space. Or it's much easier for me to read J that has spaces between the primitives, between the tokens. In APL, I don't like that.
Yeah, that's fair enough.
Do anything. I don't understand why, but like when people write verbose proper languages like C and Python, JavaScript, so on, they put spaces everywhere, and I don't get it. It's already so verbose, so little information on the screen. Why do you add more spacing? But maybe also because those languages have multi-character tokens, right? So the spaces help you sort of tokenize, whereas in array languages that use fancy glyphs and in K, you barely need that. There are very, very few multi-character tokens in those array languages.
Yeah. I mean, that's a separate issue.
The syntax calling it might be more useful if every other token had a different color. But I guess if you're not so used to the language, the syntactic role of any given token is not so obvious to you. But once you're used to that, it doesn't really add much. I know Morten Kronberg says syntax coloring doesn't really do much for him.
I mean, everybody's different, but like you can't.
But there's some utility things that I agree on. Like I mean, I do have that. When you're dealing with traditions in APL, then there's a big difference whether your names are localized or not, and having a different color or some indication of whether something is local or global, that is genuinely useful. Or maybe the syntactic type of user-defined names would be useful for me. But the primitives, whatever. Anyway, we can add color to Apple Card if you want, or I'll do it.
It's not about the color. It's about in general like. That's the website again. The goal here. I mean, we're so lost in the sauce here. I mean, this is not a failure, but we shot for the stars and we landed in a dumpster. The goal is that, or at least for me, like I had this vision of like a board that. It's not that this is the go-to place for people to learn languages, or I want to get into array languages. You start at white and then you work your way up. It's more of just like I'm hoping that you and others that are more expert can put things here that like I can target as like, for instance, I don't know if this is a concept or an expression or a technique. I guess it would be a technique, but it's like, a dyadic reduce. You want to apply a dyadic function on two arguments, but it's in the form of a list. So it's like the idea of outer product.
Yeah, but to rank.
Do I still have
So I think that one of the reasons why we end up in the dumpster shooting for the stars here is exactly that, shooting for the stars. Like, try to reach the moon first. What I mean by that is we're trying to do all the array languages at the same time. We're trying to look at all the different possibilities of these primitives. One thing I sort of don't like about the 𝗦𝗛𝗢's website or documentation is it seems to sort of say that the highest rank is 2. I know it's not the case, but if you pretend that the highest rank is 2, then instead of you first axis, last axis, this kind of thing, then it's just the rows and columns. It's easy. So I think if you remove nuance in a different way here, firstly, I would recommend starting with one language. You can always add it later, because things get really complicated when there are differences between the languages. And then maybe start with going through just the primitives. Maybe start even with the primitive functions, just to have a starting ground for like how difficult things are. And when you start with the functions, okay, split them in monadic, dyadic, that's fine. But assume that the arguments are of the smallest rank and depth that is reasonably meaningful for that primitive. So, for example, dyadic transpose doesn't make sense on a vector right argument, but dyadic transpose doesn't make sense on a matrix right argument either. It only makes sense on rank 3 and more, right? Because, well, except if you're having duplicate left argument elements for the left argument, so you're already some nuance there. But assuming the simplest application of dyadic transpose is when the left argument is a permutation without duplicates, right? Then it's much easier to speak about things. Then we know dyadic transpose is talking about vector left argument in APL's case, where it has to be a vector. So vector left argument, rank 3 right argument, and then it's way up there in the black belt. Right? For plus, even just 1 + 1. Right, that's meaningful. It's probably the most common case use of plus is just adding a scalar to another scalar. That goes down in white. Yes, there's a lot more nuance to plus, because there's scale extension, there is the array application, there is pervasiveness, right? There's and for some languages you got the leading axis conformity and bracket axis, and there's lots of stuff. But in the simplest case, 1 + 1 is very simple. It goes in the white belt. Yeah. Then build it up from there. Then we can always add more nuance, but start small. Start with a minimal viable product where you say, these are the primitives on their simplest forms. This is how you grade them. And then maybe you even have like function black belt, right? Primitive function black belt on symbols form. And maybe it's like advanced function application where you say like, okay, these primitives actually can do a lot more, and then you get like separate build for that. Or then you can start adjusting, like move everything down to just green and white or something like that. Then you can do the nuance later. But I think if you start with that, you actually have a chance of getting somewhere that has some meaningful information to the reader. I know you want to do everything, right?
But not that I want to do everything, but just like starting with 1 + 1 is boring.
You don't have to start with 1 + 1. That's boring, yeah. So, but starting with iota on just a scalar right argument, that's right.
That's what we did start with. It was right here.
Yes. Yeah, sure. But you're trying to fill out all the to cover everything. You have a little badge there in the corner saying
I'm not trying to cover everything. I'm trying to create
So now we can go in, and if you want to look at operators, I would recommend staying with functions just to get used to the process of assigning belts to the functions. So now we go through the language bar, whatever list of primitives, and just do the functions and just look at each one. What are their simple applications? That's what I would recommend, just as a starting point. So sure, you can skip the arithmetic, but where would you put, for example, monadic circle, right? Magnetic circle, I would say, is very simple. In its simplest form, it takes a scalar, right, argument number, and it just multiplies by pi. Right? So pi is a bit of an interesting number, but it's not a complicated concept, right? That it just multiplies by a constant. So I would probably put that on white, or maybe one level up from white, but definitely not more than that. Right? The fact that it's a scalar function that it can do all these stuff, right? Forget that for a moment. And then you can do the domino, magnetic domino, right? So it's not a difficult thing from an APL perspective, as in like it takes a matrix and it returns a matrix. It's sort of similar to transpose. However, it does something that's mathematically difficult. So now this, by limiting our scope like this to something quite simple, now we get to actual questions that we need to ask ourselves. Do we look at things that are the difficulty of things from an array programming perspective, or even from a concept perspective? Like 𝗔𝗿𝗀𝗁𝗪, right? It's a scalar function in APL. That makes it very simple. But mathematically, it's sort of a more advanced thing you don't really learn in basic school. So do you want to grade that as well? Is it the APL part? Is it everything? Those are the questions you want to ask instead of getting into the nitty-gritty nuance details, in my opinion.
I mean, I've used this once in 7 years, and I've never used the circle function ever.
Yeah, but that depends what you're doing. If you're doing graphics, like somebody's writing basically a Minecraft clone in APL, you want to use the circle function, right? You have to determine what is how far are things in 2 dimensions or 3 dimensions from you. You have an angle, and you need to know how many blocks this way and that way is it. Right? How far can you throw in that direction? You need the circle function. And if you're trying to solve constraints or doing like a nicely ragged adjustment of text on each line in monospace at least or something, then, or even not, then you need the domino function.
Yeah, I guess there should be
It very much depends on your domain.
Well, I guess we're just doing APL now.
That's also what I recommend, is that like limiting the scope, I think, will get you a long way.
Where do you want this one?
I mean, that depends on the other question, right? But that's a fairly easily to resolve question. Do we take non-APL conceptual complexity into the picture or not? Are you only interested in the difficulty of understanding array programming, or are you also interested in the actual concept involved? Like, or in other words, is multiplication more complicated than addition?
I don't know.
That's just a design choice. Is this the beltness of APL-ness, or is this the belt level of everything in the primitive? So if it's just in the APL-ness, then all scalar functions go down in the simple on the same level. Right? There should be no difference between 𝗔𝗿𝗀𝗁𝗪 and plus or minus, because they're just scalar functions. There should be no difference between LCM and GCD and multiplication, even though there is a huge difference in the actual knowledge and understanding here to employ them.
Okay, I updated APL Dojo with my death skulls. It has failed.
It's not dead. You just there's some choices that need to be made. What is it? If you don't write a user story first, what is it you want to who's your target audience? What do you want to achieve for that target audience?
Target audience was me.
So, okay, that's fine. That's valid. So if your target audience is you, right, that means you're already very familiar with programming concepts. That means that reduce is a pretty easy thing for you to understand, right? Or map, right? And each. But for somebody who is not familiar with that kind of thing, or if they are not familiar with higher order functions because they only program in C or something, then that's more complicated. But if you're the target audience, that's much easier.
Yeah, I don't know. I think if you convince me though that it just doesn't work.
No, I don't want
I
you to
think
give up.
array
But it's not that
languages are drowning in nuance, and any attempt to do something like this.
So Loki is suggesting something completely different. That it's more of a course indicator, saying, well, white belt means learn this stuff first. Basically, you have to decide on a lesson plan, and that's something I've done. I don't know if you've looked at lately at the APL challenge. APL challenge I've tried to make really pedagogical, where you start with no knowledge necessary other than basic school mathematics, plus minus times, basically, is all I required to know, and the alphabet. So, and then we build up from there. In that case, you say, okay, if I'm teaching somebody, and again, there's a question of who's the target audience. So obviously, it doesn't make sense to say if I'm teaching Connor today APL, because you already know. But if I was teaching Connor 7 years ago APL, what would be the first things he should learn? And they would put that on the white level. Then what would I teach him next on the green level? What would I teach him next on the blue level? That's a whole different thing. That's not a question of how difficult they are, but just of a pedagogically worked out lesson plan. But that probably corresponds more to the belts of martial arts, right? They don't say, oh, if black belt means you're doing something more complicated. That just means more experience. You've learned more. It's not complexity. So this is really the crux of it, I would say. Who is the target audience, and what are you trying to do for that target audience? And then it's not dead. Then you can do it.
Yeah, Max. I mean, that's the problem, is that everybody, there's a billion ways you could look at a thing like this. People mentioning teaching basics. Max is mentioning frequency of glyph usage and existing coding problems.
But that doesn't mean that they're simple. That's a different thing. Then it's color-coded frequency analysis. That's something else. It's also interesting to know how often primitives are used.
But I don't think Max. I think I'm more in line with what Max is thinking, though. It's that, like, I have, we can. What was the last one we were trying to add here? Is like matrix inversion. It's like I said, like I've used this once, and yeah, so that's my personal experience. But like this rarely comes.
So that goes to black belt, right? You can basically remove it from APL, and nobody would cry. Right?
Not nobody, but if you remove this versus like reduce, like obviously reduce is a bread and butter thing versus matrix inversion. And I mean, how many APLs actually have? Like BQN doesn't have it.
What, matrix inversion?
Yeah, I don't.
Well, every proper APL will have it because it's standard. It's been there since almost day one. It was.
I mean, BQN's an APL and it doesn't have it.
Okay, but that's the question of the definition of APL. Right? Anything that I would say has the label APL, has the name APL, will have it. Essentially, because it's part of the standard. There's an APL standard, the ISO standard, and if you even if you like adhere somewhat to that standard, you'll have it because.
Oh wait, so this is breaking news. Adam declares BQN not an APL.
No, I'm not saying that. But
you just did say that. You said every APL that
APL that has the APL label, right? BQN doesn't say that it is just an APL dialect, right? It's an APL. Yeah, it does say it's an APL for flying saucer.
I was going to say, doesn't it say it's like a modern APL?
Yeah, it's like, but there's some pretty radical differences too. So it's another. We can do a whole episode on what is an APL, and we've had the question of what is an IVS and Indian language, so on. So I tend to go by something like APL Wiki's definition, which is basically that it's recognizably something like APL 360 superset or something, or that you got at least the basic glyphs are the same as in good old APL, and the array model and so on. As soon as you depart, that would make J not an APL. Right? Others would argue J is an APL. It's just a matter of spelling. And of course, if you took APL as is and replaced every glyph with some keyword, then is it still APL? You would, according to the APL Wiki definition, no, it's not an APL. Madeline is saying that the APL Wiki has an APL dialects category. Yeah. And BQN is not in that list. There's some text in the APL Wiki on what is APL. It's an interesting question, but it's a whole different question, right? So that's why, like, it's amazing, this vibe coding, don't get me wrong, you can do beautiful looking things in short time, but you still have to have the human asking themselves, okay, what am I actually trying to do here? And I'm not shooting this down. I don't mean to kill this. I think it's a cool idea. I think it could potentially useful.
I mean, this has nothing to do with vibe coding versus humans. I mean,
no. But the vibe coding makes it very easy to go from 0 to something in no time. But you still need to take a step back and think, okay, what am I actually doing here? This is the APL Dojo. We're gonna grade the primitives and the expressions and the concepts and the other thing. But
no, I mean, I really push back on that. I think the problem here is that we've just decided to drown in nuance, and like at a certain point,
what kind of nuance do you want to get rid of? I'm all for removing the nuance. Otherwise, you can't put things into 5 categories, right? But what kind of nuance are you getting? Do you want to get rid of? And what kind of grading? What is we grading? What does it mean? Difficulty? Is it difficulty again? LCM, right? And GCD, they are not syntactically difficult. From an APL perspective, they are just scalar functions. They're even simple in the sense that for most APLs, that they only exist in dyadic form. So it's not even the monadic-dyadic duality there. Very simple functions. Do you actually understand LCM and GCD? Like mathematically? It requires a whole lot of number theory and prime numbers and stuff like that. So does that make the primitives more complicated? From an APL perspective, and how I usually teach APL is they're not complicated, because what I will do is I will teach people some representative functions for operators and so on from the various categories, syntactic categories, and then I tell them, okay, now you basically know all of APL. You just need to expand your vocabulary. It's like learning a new language. So learning the pronunciation and learning the writing system and learning the grammar and so on, those are hard things. But learning another word, even if it's a long, complicated word, that's fairly simple. Even if the word stands for something that's incredibly difficult to understand, acquiring that one more word in the language isn't really hard. Just understanding the concept is hard, but syntactically you can use it, right? So you can use quantum physics correctly in a sentence. But do you actually understand quantum physics? So if you were to grade English compound nouns in a list of by difficulty, where do you grade quantum physics? It's not hard to spell. It's not no complicated pronunciations or anything. It's a fairly simple phrase of 2 words. But understanding what it stands for is much harder. Same thing here. The and symbol. Syntactically, it's straightforward. The symbol is not hard. And how it behaves with data, very simple. What it does, that's complicated. What is it that we're grading here? That's all I'm asking. I'm not trying to shoot this down. We have some fun stuff going on in the chat here.
Yeah, I mean, I agree with Madeline earlier in the chat when she said that teaching is all about nuance. I mean, I completely agree. There's a reason why I'm trying to build the bells and whistles in the panel, and the same thing with the comparison mode and array box. But like, it's like when I was talking with Ben Dean on ADSP about how teaching is just a series of lying to you less. You omit stuff because right now, like, you know, and that's the thing is you're saying, what are we trying to do here? I have a very clear understanding of what I want to do. It's that other people have different ideas of, is this a pedagogical teaching tool? Is this for beginners? Is this for someone that knows whatever? But like,
I don't disagree with you, Connor. I'm just trying to pull the information out of you. What is that thing you have in your head? Because it's not clear to me what you're trying to achieve. I asked you before.
I know, it was very clear. I said it multiple times. It's that I want this to be a thing where people can look at and say, I'm roughly at this level. Here are some concepts that are like, currently I have not like learned or put in my tool belt. Because in general, like my experience in learning the array languages is that some things are just obvious. And yes, that is informed by your experience and what other programming language you learned. It's going to be different for every single person. I understand all that. Yeah. I'm not trying to ignore that someone learned Python or someone doesn't know any programming or someone is good at math or isn't good at math. Everybody's experience is different. But in general, you pick up certain primitives, certain tools, certain concepts. Like I said, for me, I learned // I didn't realize that could generalize. And like having like n-wise reduction as a thing that like you could look at in a tool. And like there's a ton of these and they exist in different array languages. But it seems like, when we have this discussion, it's very quickly just like, oh, well, if you talk about IOTA, we got to talk about, the 17 different flavors of IOTA. There's rank 0, there's rank 1. It's different between JJs. And it's just like, okay, well, then the tool can't exist because there's just too much nuance. And like, yes, we can drown in nuance, but like in general, depending on the task that and that's the thing is I have to say depending on the task because the tasks that I'm doing are different than the tasks that the graphics programming are doing. Like there in general are a set of primitives and techniques that you reach for on average more than others. And like the goal is to try and like put those on a kind of star map or a tier list that can expose them to people sooner rather than later. The fact that, prefixes is available in 𝗦𝗛𝗢 in the tuples primitive. Like if you have a prefix concept and then you can, hover over it and it shows that, it's spellable certain different ways. Anyways, but I just feels like this kind of thing, and it honestly, it makes, I don't know. If this is the way that the conversation happens when you try to build a tool like this, you have to either evaporate all nuance and just get a linear list of primitives, or it's too complicated. Like it's unsurprising that so many people bounce off of these languages because it's just like there is an easy path where you like over time learn things and you pick up a new thing. But it feels like in trying to do this, it's just like, oh, well.
I think that there isn't one path. I think there are many paths. And then it's more like what Loco was saying, like, okay, so this is a course material, but then you have to choose your path in. And I think that depends a lot on the person. It doesn't happen so much anymore, maybe because I'm not around so much. But usually when I see a new face, new avatar in the APL orchard, then I ask them, hey, interested in APL, and then sometimes it's somebody that doesn't know about APL, only heard about it or something, and sometimes I offer them like an intro course or even a full course in APL in the chat. And I usually the first thing I do is I ask them politely if they will tell a little bit about themselves, because their background, whether they have programming background and which language is their programming language experience with, if any, their knowledge and interest makes a huge difference to how I would approach them. So somebody who's like a mathematician and into like theoretical things, so I have a very different approach to somebody who is a programmer. If somebody is a child that doesn't know a whole lot of mathematics, then I'll try to avoid the mathematical things, and so on. So I think it depends a lot on the audience, and it's fair enough to say, okay, we imagine Connor, or maybe imagine Connor 7 years ago, what would have been the best thing for you, and that's fine. Just like Stefan Krüger wrote his book saying like this is the book that he wished would have been there for himself when he started learning, and there will be other people who are in a similar position to him and it'll be useful for them. And I don't think it's a bad thing to have the Connor's APL Dojo, and for people who are sort of similar to where you were 7 years ago, they would come in and see, okay, you learn these things, and then it becomes sort of a course, and you get the belt, and when you're up to the black belt, then you can do a whole bunch of stuff. I think that's fine. I don't have a problem with that, as long as it's clear what we're trying to grade. And then we can say, okay, Connor 7 years ago Were you familiar with matrix inverses? Right? No. Yes. Was it complicated? Could you pick it up? And then we graded according to that. If you want to include all the concepts that APL includes, because APL, as opposed to many programming languages, comes with a lot of. It's not really the batteries included, but it's got a lot of, especially J has, and has a lot of like mathematical things that that are included in the core language that you don't usually see included. And there are no other real world production serious languages that have matrix inversion as a single glyph. It doesn't exist. There are those that have inner product as a single glyph. But yeah, so but that I think that's fine. I think it's perfectly valid to do this. Don't get me wrong. And if this is clear, yeah, let's go for it. But then the answer to every question as to how complex this is asking you. Think about 7 years ago, how difficult do you think this would have been for you? And think about this, how difficult would that be for you? And then you can put in the various concepts. You can leave out some things, oh yeah, in-wise reduced, two-wise reduced.
Yeah.
Have you? I never really got an answer to that. Have you looked at the APL challenge lately?
Yeah, I always do it.
Okay, so you have. Again, I don't have a target audience that's a specific person, but I have in mind like kids, maybe like early teens, something like that, and trying to phrase it in such a way and build up level by level. And so there, I don't teach all of APL, obviously. I teach just some basics, and I try to make the 10th problem out of the 10 be a problem that is at least moderately interesting to do. We do something that sort of looks nice or this nice idea, concept. So, for example, the current one we built up to determining whether a square is a magic square. It's sort of a cute thing to do. So you just learn just enough to be able to do that. But we get to dyadic transpose. Okay, so this is a from nothing course, a 10-step course that where we end with dyadic transpose. So what happened? Is that black belt? No. By the end of this course, you know a fraction of APL. Tiny fraction. But you do know something about dyadic transpose, at least for a matrix.
Yeah, I mean, there's a bunch of different paths, tools, and stuff.
Yeah. I think they're all valid. And unless we can make some really clever AI that somebody is suggesting in the chat here as well, that can adapt to people automatically, maybe analyzing all the times that I've taught people APL in chat. I don't think it will actually work, but maybe. Because the problem is the AIs don't actually understand APL or any other programming languages, I'll venture to say.
That's actually not true anymore. I mean,
okay.
It successfully wrote profiling for every single one of the 6 languages that I wrote that I have on these sites. Like it knows quad underscore measure is tiny APL's thing. It knows the system timed thing from BQN. It's not perfect, but
it doesn't. Okay. Anyway, that's another discussion. There are lots of videos on YouTube of people discussing whether AI systems, LLMs, and so on know anything, understand anything. That's not. We don't have to take that discussion here. I doubt that it can be done well, but hey, maybe one day. Yeah, we can do this. Let's get going. Let's start.
We're 20 minutes past the hour and a half mark.
That means we're almost okay. Almost at the 2-hour mark. Then is how I would put it. Yeah, but I think this is potentially useful. Right? We hashed out some of the issues that are involved in making something like this. We've narrowed down the scope of what is you're trying to do with it, and the goals and what we're not trying to do. Right? It can't be comprehensive. We can't do everything.
Yeah.
I think it would be useful to not. I mean, I know you like the color, but I think that itself is a barrier to have all this color-coded and information. if I come into this as a complete newbie, it's hard for me to put myself into the shoes of somebody completely new to APL. But I do tend to do it a lot because I teach people. Right? This would be very overwhelming. Even what I'm seeing just here is already like, whoa, what are all these things? I think just some much more neutral things that even with just a name that I can read, because I don't even know how to pronounce any of this. I can't refer to the right tech because I don't know how to say right tech. So I think
but like I said, this is not designed for it's designed for me, you know?
Yeah, I understand. So that's the thing. But even for you didn't know all the glyphs either, even though you had. Now I've heard you in the various podcasts.
But also too, you keep referring to the 7-year version of me. Like, it's not designed for 7-year version of me. It hopefully is useful to that person. It's designed for me, like me now. The guy
you now, but you okay.
Like,
so, but right now you're pretty high up in your belts, right?
No, I think I'm blue. I think I'm blue.
Yeah, that's
and
also
like
what
there's
I
a bunch of stuff up here that I don't know, and the goal was to kind of fill this stuff out. And it's like, what is useful for someone here or someone here? Like, yes, I didn't know NY's reductions at one point, and so I was green at one point. I was white. It's supposed to be useful for a bunch of people, but like honestly, selfishly, the same reason that I built array box. If we can iterate over here, the reason I built this was for me. Yes, other people can find it useful, hopefully. But like, I wanted a nicer 𝗦𝗢𝗪 cap REPL. And like, the main thing is when I make YouTube videos and things and I'm always switching, and it's such a pain. And like, the docs are all over the place. Like, for some languages, they, it's easy accessible. Other ones. So I've always got like 20 different tabs open. I've got 4 different REPLs. And I can't remember all the ways to type the glyphs. And so now I have a super easy way that I can, flip through these. It's got a certain amount of like primitive translation. If I forget something, I can look at the keyboard. If I know the name, I can just like control space. Like, it's a tool I built for myself. A ton of people would probably argue it's hard to use. Where's the help? You know what? If you hit F5 for 10 seconds, it shows you how to get the keyboard, how to get the help. You know what? It's not designed for like 100% of everyone that hits this is gonna find it the most usable. It's for me, and I want it to be beautiful, and like it's also like primarily keyboard driven. It's not designed to be used with the mouse. If you bring the keyboard up, you can't really click, and I think that was a thing that like you asked for at one point. I designed this for me, and hopefully other people find it useful, and it's open for PRs. Like, there was someone who they contributed. I think I know it's been merged, but I think it'll work. If we do this, if you hover over this, someone contributed this. They were just like, this is kind of like BQN. I'm happy to accept contributions as long as it doesn't like ruin my design. But the point being is, this is a thing that I'm designing for myself and then putting out into the world that hopefully other people will find useful. But if no one else finds it useful, it's still a win for me because this is how I primarily use stuff. That's the same goal for APL Dojo. I'm not thinking about the beginner. I'm not thinking about fair enough. 100 other flavors. I'm not actually.
Connor, we're sort of. I don't know if you're running out of time. I've got time, but at some point we want to draw a line.
Yeah.
Let me throw out just as some examples, because if this is really for Connor to know, like, if you want to get better at these languages, what are you likely missing? Right, you've been going on APL for 7 years. Which means you've picked up some advanced stuff and some things you've probably completely neglected, often because the type of things you do, if you excuse the phrase, toy problems, you don't touch so much on certain more everyday business type things. Or maybe you don't do so much advanced math, so you don't touch on those things. So it's sort of hard for me to know, of course, which things you have not seen. But let me throw some things out at you that you might not have.
That was supposed to be the goal of the APL Dojo. Is that like, you don't know what you don't know, and then every once in a while you run into like an NY's reduction, and you're like, it is for a lot of people, or at least it was for me. When I discovered the NY's reduction, it was the first time I encountered like windowing algorithms in any programming language, and it blew my mind. Same thing with outer product. Like, outer product, first time I encountered it was in APL. Yes, Haskell has an outer product function in some library, but like a ton of the algorithm like ideas and techniques I discovered in APL. That is essentially what it's for. It's not for exhaustively listing out the primitives. Like, the reason that IOTA's here is because it's like, I don't know, a bread and butter kind of thing.
Yeah, but like, I get it.
ideally this is fleshed out with like the most coolest, like unkeep from 𝗦𝗛𝗢𝗪, which is like run length encode, and a bunch of those things that like people can at a glance hover their thing and be like, oh, that's cool. And also for me, I'd like to be a black belt, but this is supposed to be like a hack, and it would work better if we had the full panel of a bunch of different people from languages contributing the best techniques. But anyways, go ahead and throw out. I can probably go for like 10 more minutes.
Okay, I'll throw a couple of things at you. Just think off my head. Sometimes you want to normalize an array so that it's not a scalar. Are you familiar with 1/ in APL?
1/? No, but also too, I was kind of catching up on the chat, so I missed the first little something with the scalar.
Okay, so sometimes you want to normalize. You want, if it's a high rank array, keep it the way it is. If it's a vector, keep it the way it is. If it's a scalar, you want to ravel it. You want to make it a one element vector, so you have an axis to work on, right? So how do you normalize an array to always be at least rank 1? You can do that in APL with 1/. That's a cool technique. You might not have realized. It's just an example of.
I definitely didn't know this. So.
Okay, so this doesn't. It's a no-up for every array except a scalar. For a scalar, it does a ravel on it. So it's like ravel if scalar.
Yeah. Okay. So we need to. So what is this? It's a monadic function expression.
It's not a function at all. Right? It's a snippet. You could wrap it to become a function, but it's because of expression. Yeah.
I mean, but it's a monadic.
Oh, there's a bug here in the dojo. Only primitives can have that subtype, right? Expressions and concepts don't have subtypes.
No, I added this so that it would. You were the one that pointed this out when I sent you. It's that like, oh, these have derived arity, right? This is a monadic.
Yeah, but this one does. This one doesn't. It's not a monadic function at all. It's just a snippet. It doesn't. You can't assign in dialog APL. You cannot assign this a name. It's not a valid syntactic construct. It's just a snippet. It's a technique if you want, or an expression. It doesn't have a value. If you enter this into the REPL, it will error.
But you're applying this monadically, correct?
No. Yeah. The point is specifically replicate with a scalar 1 as left argument. Right? So the way I write it in Apple Card, I would write 1 𝗔𝗿𝗏/, but you don't actually want to ever write the 𝗔. Right?
So, but I'm confused though. But we did not just apply this.
It's a technique, right? No, this is dyadic / 1/ is not a thing. It's dyadic / is a function. It's applied with 1 as left argument and iota 6 as right argument. But it's a technique. It's a tool in your toolbox to write. Oh, I need to normalize this so it always has at least one axis, 1/.
I mean, this is what I mean. This is what I mean by drowning in nuance. So, like, the point that you're making is that, like, this is a valid expression.
You can write that. Yeah, sure. This is a valid function, right? A derived function, 1 𝗔𝗏/. But that doesn't matter. I wasn't even trying to argue with the delinearization in the APL Dojo. I was actually trying to give you a useful tool in your toolbox that you might not have known about. Right? It doesn't matter how you categorize it. It's up to you. In Tiny APL and in some other in K and so on, it would be considered a monadic function, the monadic derived function, I guess. But that doesn't categorize it as you want. Okay. It's a useful thing. Yeah, sure, put it like that. Yeah, but that's not. Yeah, okay. It just doesn't describe what it does. It's just a symbol, but yeah, that's fine. Yeah, you have to grade it. Okay, good. Are you familiar with how to count, if you have a Boolean vector, to count the number of trailing ones? Like the tail end, how many ones are there at the tail? You ever seen that?
It is. I've seen you do it once. Like I could solve it.
Yeah, uptech commute, uptech self, if you want. No, yeah, this one. Yeah, and then you like 1 0. Yeah, whatever. It doesn't matter. Yeah, so this gives 4. This is a nice tool in your toolbox. It doesn't have a name as such. And special, maybe. And you're aware of dyadic transpose with all index origin left argument, right? Gives you the diagonal. It's complete nothing to do with this one. I'm just giving another one that's like something that to put in a tool in your belt. So sorry, I'm just going too fast. So this is a monetic function. Yeah. It's not a primitive, but it is a monetic function. Yeah. Okay. So for a matrix especially, 1 jot transpose. This one you're familiar with? You should be if you've done the APL challenge. So so 1 jot transpose you don't actually need the jot normally, but if you want to make it a function, then yes. On a matrix, it gives you the diagonal.
Yeah, I definitely didn't know that.
Okay, you didn't know. So that's nice. That's the diagonal of a matrix. That's how you do it. Okay, here's another one. If you got a positive number, you want to split it into the integral part and the fractional part, you can write 10 jot encode. You ever seen that?
10 jot.
You don't actually, again, you don't need the jot, but yeah, just to make it a function. Yeah, so you write 123.456. You split it. Sorry, this is wrong. Did I say it wrong? 0, 1. I'm sorry. 0, 1 in, yeah. So it splits it into the integer part and the fractional part. That's sort of a nice thing to do.
Is this just like a custom?
It's not special, right? It follows from the definition of encode, but it's a technique. It's a tool to have in your tool belt. Like if you know this one, you're like, oh, I need to split this number into the whole part and the fractional part. Yeah, that's how you do it. Right? No, otherwise you start with like, oh, the floor conjugated with, and then it's like the original number minus the floor. Right? Yeah, but this is much easier to do it. And here's another one. Let's say you have a matrix and you want to rotate it 180 degrees, not flip it upside down. That's just a first axis reverse. You want to actually rotate it. So that's you do a rotate first, rotate last.
Yeah, I think that one I've seen, but that one just kind of makes sense, right?
Yeah, sure. But what about rotating 90 degrees left and right? Yeah, so this doesn't rotate, right? Upside down. But if you want to rotate 90 degrees, you got, for example, last axis reverse transpose that rotates clockwise, and transpose last axis reversed rotates counterclockwise. You could also spell them with the opposite order with first axis first. That doesn't matter. But there are two different spellings of each one. So now you've got all the rotations of a matrix: 90, 180, 270. But
that was covered in a challenge, wasn't it?
Maybe. I don't know. Yeah, that kind of thing, right? So you've got all the rotations. So those are things I would say. Those are good techniques to know.
Yeah, how do you classify those though?
I mean, they are just two trains, right? So you could just take them and put them into
you don't want to add all of
them
though. I don't know. You'd say
exactly. So so there's rotations, right? The rotations of a matrix, rotations and yeah.
Call it a concept.
Yeah, matrix rotations, sure. Here's a completely different thing that is good to know. Like basically all the entries in Apple Card you could take. Like, what about an identity matrix? Right? What's the best or fast way or whatever to make an identity matrix? That's a thing that's you should learn, so you don't sit there and try to piece it together.
Yeah, I guess that would be depends on where outer product would go, and where like
Well,
the comp
but that's
names would
not a good
go.
way to make it. Really, it's not a good way to make an identity matrix, because using an outer product selfie of an iota range, right, makes a giant number, right? It's the n squared number of comparisons for no use whatsoever when you already know what values are going to go in there. So what's better is to do a 1 followed by n zeros and then reshape that into n by n, right? So like, right, 4 4 reshape 0 comma 4 reshape 1 4 4 reshape 1 comma 4 reshape 0. Right, this is the better way to do it, because here we're not computing anything, we're just reshaping. That's the fastest. You're just doing memory copying operations. There's nothing else the computer can do faster than this. And especially since we're using bit boolean, it's gonna be, right, it's literally just writing bits out in memory. Whoop. That's a thing you should know if you didn't already. Yeah, exactly like that. And there's an entry in Apple Cart that looks something like that, right? Of course.
Well, yeah, this definitely.
I would write it in a tacit form, but that's just me. It's comma selfie reshape 1 comma reshape 𝗔𝗿𝗏𝗪 if you want, but whatever.
What is it tacitly?
Yes, comma selfie, right? That makes the omega omega reshape 1 comma reshape 𝗔𝗿𝗏𝗪. It's a train. I like that. Whatever.
Keep switching the wrong tabs.
There are other ways you can write it as well, but whatever. You could, instead of the 1 comma and the reshape, you could do an overtake, but whatever. There are different ways to do it. It doesn't really matter so much. But something like that, right, is good to know. Okay, so these are all things that I would say you should learn as an APLer. You should just reach for immediately, without really having to think about it. And then you can use those to build up. Right? It really is like Lego bricks. So an APL that has a higher level build, they don't have to think for writing certain things. Like, for example, the average, right? If you're given the task as a new APL to write average, then you might need to sit and think about it. But you can do it in your sleep, right? It can wake you up in the middle of the night and ask, how do you do average in APL, right? And you're right. +/bar divided by tally. Done. But that's something that, right, that is something you sort of have to know. Right?
Yeah, maybe the better way to do this then is just with idioms, basically, because this is what they are.
That's what. But we can go to something completely different, right? This was just some examples of some techniques, right? That I would say you have to learn in order to become a black belt APLer. There's many. Basically, you have to know Apple Cart, right, by heart to be a black belt APLer. But there are also other things that you should know about. For example, how to use namespaces effectively. You ever use namespaces in APL?
Nope. I mean, I've seen them used and I know what they are. And I've saw when we had Tacit Talk episode 30, you demoed a bunch of stuff. But
Oh, right. So now with version 20 in dialect, there's a whole bunch of stuff that you should know. That's essential. Being able to decide on how you structure your things. How about error trapping? I would say if you're writing a production system in APL, you better be able to trap any errors and deal with them and write and report that you send by email to yourself, so you can go do something about it, right? And don't have the user system crash. So collecting information, pertinent information from the system when it crashed, and catching that and dealing with that. Have you ever used traditional functions in APL?
I think I've written like one or two, but I
Right.
prefer the
So
defun
all
ones.
the
So.
I understand, but sometimes you need control structures to write something sanely, I would say. I know DQN shies away from that, but with the type of program I do, I very often have like giant switch statements with loads of different things that I need to do, or for loops and so on. So that's something I would say you should know about. Even object-oriented programming in APL, that occasionally is useful to use. If you've never used that. For example, right, if you're writing some object that represents something, some connection to some database or something, and the user can set all kinds of options, and you need to like normalize the settings that the user uses or check that they are valid. So they might be exposed as fields, but then you don't have a chance to check them until runtime. If you expose them as properties, then you have a getter or a setter that checks when the user assigns to them that the value they're trying to assign is actually valid. All those kind of things. That's stuff you need. That's bread and butter for the applications programmer, but not for toy problems from lead code, of course. So there's a bunch of stuff there to learn. How to effectively use regex in APL. I don't know if you've ever used regex in APL at all. So
maybe.
Max is saying in the chat that error trapping and tradfans are beyond Connor's use cases. But if the question is, or how does Connor become a black belt APLer, right? Then what does it mean black belt APLer? In my mind, it means you could work as an APL consultant, right? One of those companies that use APL, they can say, hey, we have some code that needs to be worked on. Can you come in, have a look? It's running slow. Can you make it faster? Or we need to implement some new functionality, and Connor is able to do that. That's, I would say, is a black belt.
That's not my definition. Definitely not.
So how do you define it?
I'm more interested in like the algorithmic ideas. Like all of these things, I mean, some of them are more idiomish than algorithmic, but like, like this is a great example of like every single time I ever spell an identity matrix, I use the outer product selfie iota,
which is fine. It's easy to understand and explain, but you understand why this is better.
But yeah, this is really good to know, and I feel like I probably should have known by now. And also too, going back and forth with 𝗦𝗀 on Twitter over the weekend, he was talking about optimizations of bit arrays and how the problem I was working on was a string of ones and zeros, and he immediately, his idea was to convert it to a bit array of integer ones and zeros, and that's not really something I think about because I'm not typically thinking about like performance-oriented APL programming or BQM programming or whatever array language. But then as soon as I start to profile things, I am looking for that kind of stuff. And then, 𝗦𝗀, I think, is thinking that way like 100% of the time. He's always thinking, what's the way that I can make this run faster? And so anyways, Max is absolutely correct that like error trapping and tradfans, going to tradfans and to need control structures is like a limitation of dialogue. It's not necessary from a language point of view, right?
Okay, sure.
And also too, just like tradfans in my mind are much more difficult. Like the barrier to writing a tradfan is a lot higher than like a defun, because of the fact that you need like, what is it, a minimum of a couple lines to get the deltas. And I don't even know the syntax off the top of my head.
That's just a syntactic thing. Okay, so here's another thing you might like. Sometimes you want to do like Lisp style, I guess. To take the first element and then all the remaining elements, and that you can do with one jot. What is it called? Partition enclosed.
One jot partition enclosed.
Yeah. So if you have one enclose or whatever,
this one?
left shoe. No, just plain one. Yeah, and then write like quote A B C D E or something like that. Right? So it takes the first element as a vector, one element vector, and then the rest of the elements. I think that's pretty neat. Nice technique to have.
So that's interesting because, like, as soon as you mention this, my thought is that in cap, and I guess you need pair.
Yeah.
I guess
so this was one drop and one yeah, sure. But this is not pair. You need comma or include or something.
Yeah.
Does it have pair? Oh, it has pair. Yeah. Oh, so yeah. So that's similar. It's not exactly the same, but yeah, it's similar enough. Yeah. Sure. It's a technique. It depends on the language. It's a fairly recent extension we did to allow you to do this, but I found that useful on occasion. Here's another thing that's really useful that I've had to tell a customer about multiple times. And that is these days you spell it comma square bracket iota 2 close square bracket.
Comma square.
Oh, that's
comma square bracket iota 2.
Yeah. Well, you can't do it on a vector. You have to, so the way you have to do it on a like a 3, 4, 5 reshape quad A or something. Yeah. So this merges the first two x's. So if you don't have anything in front of the 3, 4, 5, you get like a three layers that are each 4 by 5, and this merges all the bunches together all the layers into a single matrix. You can't see because of the boxing here, so it's hard to tell. But it doesn't. If you turn on full boxing or something, I don't know if you have that. But if you do it on, I think your output is missing spaces. Try to stick a. There's something funny. Yeah, you can't do that. Try to stick a format in front of this. I'm not sure. There's something wrong with the output. This is not. Okay, it looks like your array box doesn't render empty lines in the output, which is a mistake.
Yeah, I think there might be a bug because I stripped those at one point.
Yeah, that's about. If you go to try APL, you can see what's happening, or just open the APL and what? Oh.
OBS
that
is
works.
Slowing down my system.
Yeah. Okay. So now if you write this is not going to fit on the screen. Yeah. Okay. Okay. See now, so this has got 3 layers. Each one of the layers is 4 by 5. And then if you do the comma square bracket and iota 2 close square bracket, then it will merge those two. Merge the leading 2 x's. And you can merge any number of x's by changing the 2 to a higher number. So if you write iota 3 inside, you will merge all 3 x's. Then it's just a normal ravel. So it's basically like a leading ravel. That's a very useful thing to do. Another useful thing to do is so Max is saying you can spell what we just did with a rank, and I will challenge you to do so, at least without using transpose. So go for it, Max. You're up. Here's another thing. If you got, let's say you've got 3 matrices of the same shape, or even more common, you can try this. So write like open paren and like 3, 4 reshape quad A, for example, and then close the paren, and then open paren and like 2, 4 reshape, say quad C quad A, just if you can see the difference. And then you can add one more just for good measure. So you add the open paren and then like 4, 4 reshape quad D or something, so you can see the difference. Okay, so now we want to stack these. So you can see these are rows, right? These are collections of rows, and we want to merge them all into a single matrix. So how would you do that? So the way you do it is disclose comma bar slash. Which is not the same thing as a mix. If you do a mix, then you end up with a 3-dimensional array with padding, and then you can't fix that. That's the split. And you need the parentheses. See, that's not useful. And you can't even do anything to merge. Now you have to remove the rows, but you don't know which rows were inserted, so that's not what you need. Right? So that's the technique. Disclose comma bar slash. Very useful tool to have in your toolbox. Join matrices.
All right, last one.
You need
We've
one
now
more,
set the
or-
record
or
for
this is
longest.
longest episode. I mean, there's a ton more we can do, right?
Well,
But this is
we
definitely
spent too
something I
long
would
on
say-
nuance and never got to.
No, it was good. It was necessary.
I don't think it
worry,
was
it's not lost
necessary.
time.
I don't think it was necessary. Even the jot, like this jot is like a beginner, like, and technically in certain cases it's necessary. Like I can't remember if it was you or someone made the comment that when I was building the comparison tables on a array box, what was this for? It was for first, and when I was doing this, and if you switch these to nested and nested, initially I didn't have these ats, which I understand that they're not valid expressions, but like, do we need to explain that?
I think they should be. I'm in favor of making I don't like the 2 trains being hooks and J, but I'm in favor of making what we call AF trains valid, so you can. But that's a different.
Yeah, I don't know, and like honestly, like this is what makes me really like CAP's 2-train model, because there's no difference. Like I think it's such a wart, and maybe wart's not the wrong word. Such a I don't know the exact word. Like deficiency is too strong, but like it is so nice in the CAP 2-train model that 2 juxtaposed functions are the same, parse the same, whether it's tacit or there is a argument on the right. And like the reason that I ended up adding these ats is because I've set up a unit testing system in the background that like tests every single one of these expressions on input and expected output, so that like if I want, I can go and mess around with these to change them and then check, does it still give the correct result? And in order for that to work, you do need the way that I set it up. You do need these to actually be correct tacit expressions. But like, you could argue that like you don't actually need these because, are people going to expect what?
Yeah, what you're saying is it would be a snippet.
It's
right?
a prefix of a non-tacit expression.
Yeah, of an expression. Yeah, exactly.
And that's like the same thing here when we're talking about like, oh, this isn't a monadic function. Yes, I understand that like technically what you're saying is correct, but I don't think that like the jot not being there is detrimental to the understandability. Because like a lot of people that are beginners that don't understand that it doesn't parse as like a function are just going to copy and paste this into whatever REPL they're using and then put an argument.
If they put it into an expression, that's fine. But if they try to give it a name to save it for next time, it will fail. And that's one of the reasons why I think we should allow saving that. I think we should allow, for example, like diagonal gets 1 transpose and not have a jot. I think that would that makes it so much nicer. And we often speak about it. We often speak about some function with a fixed left argument, because the left argument is usually the control argument. So the pairing of a left argument with a function often has its own meaning, and having to insert a jot there, I think, is just unnecessary, especially since syntactically it's unnecessary. And there are a lot of entries in Apple Card that are of the form argument jot function. And I think it's a pity that I have to do that. I think it would be much nicer if I didn't. But be that as it may. However, your notation for it is, We can stop here. There are a ton more of these like short snippets and things. Bunch of them are on Apple Cart of things that I think one should know as a black belt algorithmic APLer, even if you're not writing applications. I think there's so many things that you should be aware of. Some of it to do with quirks in the language. Some of it is just using primitives in ways you might not think. I'll give you one more. Sorry, Connor, I'll give you one more. Let's say if you go over to like ArrayBox or something, so you can play with this. So let's say we have some phrase, and so like a in text phrase, just easy to understand, like your name or something like that. Right? A dog. Yeah, that's fine. Yeah, that's fine. Okay. You should probably put single quotes like that. Okay. So you know how you can remove all the vowels, right? So without, and then a list of vowels. Well, it's the other way around, but yeah, you need to do without. You can do a commute on it if you want. Yeah. And if you put instead an intersection, then it finds all the vowels. You want to do you want to do commute there again. Yeah. Right. So this. Now that is basically just a primitive. You put in commute, but you could just have reversed the arguments. Of course, it would be the same thing.
Mm-hmm.
It's just a primitive, but I think a lot of people think of intersection as being just for sets, and this can actually be used for data extraction. So sometimes you have in some kind of problem where they have some digits and they've got some letters in between, and you want to extract just the digits. And so then you would write that. So if you remove everything to the left of the cursor right now, right, and you write one dog, so change A to a digit 1, example.
A to a digit 1.
And the second A, I changed a cat, change that to like 3 and cats. Right? So let's say you have some parsing problem like this, and you want to extract the digits that are in there. So at the end of the expression, you just write intersection quad D. Yep. Now you could do whatever, execute each or something like that to get the numbers. Right? That's a technique that I would say you should be familiar with. It might not be so obvious. Maybe it is obvious. It's just a primitive. There's nothing special going on here. But these kind of things. And how do you write this? This is.
I mean, there's the more complicated one where you need to deal with juxtaposed digits, and Marshall has a thing in BQN just called ints or nats that is used for adding.
So we can try that. If you write, so if you get rid of the each here and after the quad D, after quad D, you can write commas, quote, space, quote, for example. There's one way to do it. There are many ways to do it. Yeah, and now you can just do an execute on the whole thing.
That presumes that digits are followed by spaces.
No, it presumes that there's at least one space between all numbers. They can be anywhere. So even if you remove the space between 1 and dog, and between chased and 3 and cats, it will still work as long as there's at least one. So no need each, just execute if you want to get the numbers. And we can do even better, because there are things like quad VFI, the system functions you can use for this if you want. Maybe you call that not pure anymore, but there are lots of, like, this also shows there's a whole area that you should know as a black belt APLer, even if you're just doing algorithms. There's a whole area of knowledge of how do you extract easily the parts of the data that you want. So I'm not saying this is the right way to do it in a production system. Of course, if there's no space between dog and chase, this will fail. But there are other ways you can do this, and that works nicely.
Right.
So if you write quad C in open paren, quad C, quad A closed band quad VFI omega that will work no matter what's in between them. It basically means split and convert. It does the execute for you. Numbers separated by any number, any letters. Why don't we just spell it out again?
No. We'll stick with this one.
Right.
We're now past the 2.5 hour mark.
Yeah.
We gotta.
Yeah. We gotta go. So I'm saying there are things that are techniques like this. This is what I. So even if you say, right, you just want to be an algorithmic expert, you got to know these, right? You can't sit and spend time thinking about how to do this kind of thing. You just got to know. And there's so many more, right? We could do a whole episode just of these, but essentially, I've put as many as I could into Apple Card. That's one of the points of Apple Card. You got to know Apple Card.
But aren't there like thousands of entries in Apple Card?
Yeah, there are almost 4,000, but many of them are not techniques like this. Many of them are just primitives.
Is there a way to filter by these, like idioms? That's the thing, is I don't think of Apple Cart or BQN Crate as like idiom repositories. I think of them as like just a very exhaustive, or not exhaustive, but a very long list of expressions that you can find useful. So if you need to know how to do something that you're struggling with, you pipe it into BQN Crate or Apple Cart, and it's likely to show up.
Yeah, there's no information in the table in Apple Cart that tells you, like a flag saying this is in Connor wants to be in
it's not just me. APL, I guarantee you there's other folks out there that want to collect these as well.
But right? like you're right. There's nothing in the Apple Cart table that tells you this one you have to know in order to be a black belt algorithm person. That's true.
Yeah, that'd be useful. Although that'd be a lot of work. Going through 4,000 entries and flagging.
Oh, I've gone through those 4,000 entries so many times. So I'm not sure if that would be a lot of work, but it's sort of an arbitrary criteria, right? What about things you have to know in order to deal with text manipulation, right? Or things you have to know in order to do math in APL, right? That's another flag. So yeah, we could do a lot of Boolean columns that say that, so that you can say like, these are mathematically necessary things to do for like this level of mathematics. These things you need to do for text processing. These are things you need to do for accounting. These are the things you need to do for, et cetera, et cetera. We could do that, but that, like, what? There's no limit. There's no end to the number of subjects and fields of study that exist, and for every field of study and every interest group there is, marking for every entry in Apple Cart whether it's relevant for that. It seems a bit much, maybe. So instead, you read through it. You could filter out all the primitives, all the system functions, all the user commands, and so on. And then you go through them. If you take 10 a day, you get through it in the course of a year, right?
Yeah, that's true. I mean, Max in the chat's just saying, so APL Dojo could be belt-based rankings from Apple Card. In the midst of Madeline, author of Tiny Apple, and Elias, author of Cap, discussing implementation of primitives. But anyways, this has been an interesting episode. We did end up kind of where I was aiming to go, with a lot of nuance along the way. And has me, if anything has come out of this, it's got me convinced that, well, would it be the ideal? But I was talking to Madeline on the last Tacit Talk that she has empty syntactic space for non-banana bracketed primitives. So the trains need the banana brackets, but then it's empty syntactic space when they're not there. And I said, well, you could technically have like a hybrid tacit model and borrow. You wouldn't even need to borrow everything necessarily from Cap, just like the two trains in the form of the monadic function composition and left bound functions. I wouldn't even really miss the B1 combinator that much. But even if you just had juxtaposition, of left bound, so aka an argument on the left, and the monadic functions, that would like be so nice. And like it would avoid the problem that we have with the 𝗔𝗿𝗏𝗆 in dialog APL and the @ in J of that. Those things just parse correctly.
It is available syntactic space in dialog as well, right? We can make array function be a valid construct in dialog APL. It's not that's the ship hasn't sailed, and which it doesn't make it the same thing conceptually as the left-bound functions, if that's what you call them, but effectively that's what it gives you, right? Because in a train, that would mean you can put. So we could do however far we wanted, right? You still have to do a 𝗔𝗏𝗏 when it's in the middle of a train, but.
Wait, what are you saying that is? And also, wait, to answer in the chat, Elias is asking, is banana brackets the official term? Madeline says, I call them moons. At one point, I was calling them moon brackets, but then I read a 1987 or 89 paper called The Introduction to the Theory of Lists by Richard Byrd, who is the algebra of programming. And he was calling them banana brackets back then and uses them for like list notation. And so since then, I've been calling them banana brackets, but it's not like the official term brought to you by Madeline. It's a term that I read in a paper from like, what is that, 40 years ago. And then I started using them. So what is all right. And honestly, last thing, we're going to hit like 3 hours now. And I guess Elias was the one that messaged in at one point that he said he wanted 3 or 4 hour episodes. What's the thing that there's still, because you definitely can't have monadic functions in a row because that space is taken.
No, but essentially, right? If you write in APL 1 plus 2 times divide, right? It looks like you have left-bound functions.
1 plus 2 times divides?
Yeah.
Okay, yeah. So AGH fork and then an AGH fork.
Yeah, this is fine, right? The one thing you're missing is that if you want to do 1 plus 2 times 10 divide, that's not valid.
Right, because you need the tack then.
You have an extra division symbol in there, right? And that tack, or you can put a 𝗔𝗏𝗏 if you want, right?
A 𝗔𝗏𝗏
Between the 10 and on the left of the right? And that could just be removed. That requirement. You could just say if the second carriage, so to say, of the train counting from the right is an array, then there's an implied 𝗔𝗏𝗏 or right tack or whatever. Right?
Oh, I see. So you're saying this is empty syntactic space.
Exactly.
So you could add left-bound function. You could add a part of the cap model. So you couldn't add the 2 trains.
No, but inside a longer train, it already works, right? You have effectively you have the left-bound functions because you have AGH trains. So that's not a problem. It's only to the far right that there's a problem.
You're saying AGH trains essentially are already this?
Yeah, just if you go back to what you had read before, the 1 plus 2 times divide, right? And then put that in parentheses. Right? It looks like it's a 1 plus applied to the 2 times applied to the reciprocal. So it looks like you got left right. This works identically in cap and in dialog, right? And in K. Even though 2 of the languages, cap and K, have left-bound functions and dialog doesn't, but effectively works the same because there's no notational difference between left-bound functions used in this manner.
This doesn't work in cap, does it?
You have to give an argument. Yeah. Well, I mean, this is just an expression. Now put parentheses around there about everything.
Because I was going to say this is reciprocal, 2 times the reciprocal, and then 1 plus that. So that's a different thing that you would get.
Right? How?
Is it?
The reciprocal of 10 is 0.1 times 2, 0.2, 1 plus that, 1 plus 1 plus 1.2 or 6/5.
Yeah. The fact that this is an AGH fork doesn't actually...
It doesn't matter. That's what I'm saying. So notationally, there's no difference between left-bound functions and AGH trains when it comes to this. The difference is on the far right. Right? And, of course, the ability to stack monadic functions that are not left-bound. The way that that's solved in in BQN, for example, is by having the nothing, right? So then effectively you have AGH trains where the array on the left is a nothing, and then everything just works out. So you have, if you had by convention a left argument that signals to the function that don't use me, just pretend I'm not here and just run your monadic function definition. So
food for thought. I'd love it in Dialog APL. I'd love it in TinyApple. Or I'd love it in some new array language that doesn't exist.
So I think I'm not sure I would add nothing. I don't think so. I don't think it adds anything. No pun intended. But I think I would add the AF train, if you want to call it that, or left bound, whatever you want to call it.
Yeah. All right. Well, we got to call. We're at 2 hours and 46 minutes at this point.
Yes. My food has been served. My dinner has been served and is now getting cold on the table. I've been sent a photo, but from my wife, of my food getting cold on the table, and it looks delicious.
My wife just popped in and looked very confused. As what are you still doing podcasting? Anyways,
so are we launching the APL Dojo podcast?
I mean, no, we're not launching a separate podcast. That's for sure. Will we revisit this topic? Maybe, maybe not. I will push these whatever changes to the live site and link it for folks that are interested in, and they can play around. But I think we've talked enough about the APL Dojo for at least a few episodes. If you do have comments, thoughts, questions, you can either leave them in the YouTube description or reach us at, here we go, contact@arraycast.com. First time since the relaunch of ArrayCast 2.0 era that we got that right. And yeah, thanks for everyone in the chat. Oh, we've got people asking for a 24-hour charity stream ArrayCast episode. No, I don't think we could do a 24-hour conference. But yeah, Adam in the chat saying I'd do it. Yeah, I don't know. We'll see. I've thought about doing like an online conference, a RayCon kind of thing, which could go 24 hours, but you need multiple people hosting. Anyways, thanks for everybody in the chat. Leave comments in the description, or you can reach us at that email address. And with that, we will say happy array programming. Whoa, nailed it. Thanks, everyone.
Bye.